routing, what routing package we're going to use and why. So I'm actually going to start from a why. Now we can look at the user interface and we can see we've got a normal screen, just a plain screen with buttons that route to different screens. So any routing package could totally work for this. But when we go beyond all of that and we get to the home screen, we can see we get exposed to a bottom navigation bar whose buttons not only open pages with their own navigation stack. These pages, for example, the Explore, which is this, when you open up this, when you click on that part of the navigation, it opens up an Explore page, but the Explore page doesn't have its own route, meaning it doesn't cover up the entire page. It's still under or underneath or part of the main navbar's stack. So the navbar is more like a parent route. A parent has its own parent navigation stack, and every other page is being launched, while some of them still live under the navbar's stack. Right, so that is, I think we did that in the previous tutorial where we had the Education UI, Education app, where we created a custom stack all by ourselves with a controller, with a provider, I believe, and that was quite simple to do. But this time we're going to do the same thing but with GoRouter, because GoRouter has already handled all of that. So we're switching up the game a little bit. Now with GoRouter, we've got this already handled for us. I'm at the GoRouter's documentation, their pub.dev, and you can head over to the documentation and you can find this. Go ahead and read all of this, but what we're particularly interested in would be the shells. The shell routing. You can see all of this and read all about shell routes. You can see regular routes. For example, the pages that we're looking at have used regular routes, but what we're looking for would be the shell route. Now, according to this, if pushing a new screen without any shell route, so assume that you've already got a shell, right? A shell means a route that's got sub-routes in it. Alright, so for example, a navigation stack, a bottom navigation stack, a bottom navigator, it's got pages that are expected to be pushed when they're tapped. Alright, so if pushing a new screen without any shell route onto the current screen with shell route, the new screen is placed on top of the current screen entirely. So that was a behavior that I was trying to avoid, where when you pushed a new screen it would cover up the entire page. However, if pushing a new screen with the same shell route as the current screen, the new screen is placed inside of the shell, and so that's what we're looking for. The ability to push a new screen without replacing the entire navigation stack. Now, the normal bottom navbar in Flutter would let us do something like that, but it doesn't provide us with a whole different route on it for the new page that we've pushed. So when we do a navigator.push or pop, it still pops the entire page. Now you can work around that. Like I said, we did that in the previous tutorial, but in this case we want it all handed over to us very neatly. So we're going with GoRouter, which is also created by the Flutter team themselves. So we can go ahead and look at the proper documentation for the shell route itself. You can see flutter.dev. We could go ahead and look at the shell route with multiple navigators. This is the shell route class. You can look at the examples and find out how to do that for yourself. Alright, so this is it. Package of the year, package of the session, not the year. GoRouter. So that is it. Let's head over to the code and configure our router. Now, quite obviously, the very first thing that we need to do would be to add Flutter pub and GoRouter and Flutter pub get. That's done. So we could go ahead in the core folder. I personally prefer to put my routing in a services directory, and I put that in router.dart. Now, the issue with this is that you end up having a long list of routes, and that causes a lot of imports, because the imports are not only about the routes themselves, the pages themselves. We sometimes have to inject blocks or controllers or riverpods or whatever state management you'd like to inject into the tree, because sometimes you have to do that depending on the state management solution you're going with. Now, if that is the case, you'd have to import all of those things. You could also have to import other stuff that your views need. Don't know, caches, other libraries that you were using. If you're going to put any logic in your routing, you'd probably have to import a lot of other stuff as well. So for that reason, I personally don't put my import in the same file. So I usually create a different file, new Dart file. This is actually not only for routing. I do this whenever I have a module that is going to have a lot of imports, so I split them. So in this case, I have router.main, which is the main file where all of the business logic for routing will live, and this will actually be where the imports will live. So this is for the imports. You could go ahead and call that router.imports.dart. However, I want to import this into any file where I'm going to use the router. So for that reason, I don't want to be importing the router.imports.dart. I want to import router.dart, plain and simple. So basically, it's just personal, my preference. So you could go ahead and call it that if you need it to be that. But I'm going to make this have a part of the router.main, and router.main will be a part of it. So sorry, that's router.dart, and now they're linked. So this is the first part of the routing, and this is the second bit. Alright, so now the very first thing we'd have to do would be to final router would be equal to go router. Now when I do the go router import, first of all, you can see that the router has got no imports, but the moment I do this, in fact, I'm going to open this on the right, so that way we can see that happen live. So import go router, and the import automatically goes over to router.dart. So, and then finally we can put in the route. Nice, and we can add any routes that we want in here, and you can also enable debug log diagnostics to put logs to see when you navigate there or there. It will tell you that you're navigating from this place to that place. I usually set this to true, personal preference. You can change that, and then the initial location. Again, you can read documentation, but that's not what we're here for. We're not here to learn about go routes. You can use whatever routing you want. You can use navigator, whatever you find pleasing, you can use it. I don't really mind. It doesn't matter. But just know that you have a router, and you're routing. Now for the main configuration, I'm going to go over to the main.dart. Nice. And over here, where is it? Yes, so right here, I can remove that home with the weird thingy. Add a comma, format. Beautiful. Now finally we can have the router. No, I have to change this to a router material app, and then finally the route config. Nice. And then we can go ahead and pass it the router that we have from the, as you can see, the router.dart. So this is the actual reason why I chose to leave this as the main router.dart instead of saying router.import, because it would look weird importing imports. So personal preference again. So moving on, we could go back to our router, and we can then start setting up routes. Now the very first route, as you always know, should always be /. Now the very first route that should match that / will actually be a decisive route. So it's going to push us to either the onboarding or the login or the homepage dependent. So if it's the first time, we push them to the onboarding. If it's not their first time, we check if they're not logged in. If there's no valid token, we push them to a login page to do the login and fetch a token. As you already saw in the back end part of the tutorial, that's how the authorization and authentication works. And then after that, if there's a first timer, it's false, and they're logged in, we have a valid token and we have a valid user ID, then we go ahead and push them to the home page. And this happens every single time that the page loads. So for that reason, we're going to put all of that delay in a splash screen. So in this case, our splash screen is not just a fancy display of our logo. A splash screen in this app will actually help us to load things beforehand, so preload stuff. So we will do all of that validity checks of the tokens, expiration, if it's expired, if it's still valid, if there exists one. So we do all of that on the splash screen and then push them to the proper screen depending on where we are or on what value we get from the logic. Now, moving on, we're gonna have to do the onboarding screen and the splash screen. So in order to create those two, we will have to go over to our lib and create a new Dart file. Now this will live in the source, right? So remember, I told you in the clean architecture, in our modified version of the clean architecture for Flutter, we have a core folder which basically holds logic that every feature will depend on or will use essentially. Now the source folder will be where the features will live or where other things will live. Some people actually prefer to call this features, as I mean, it tells you what it does plainly, but I prefer to call this source. I don't know why, but so I just prefer to call this source. And then in source we will have the onboarding. Alright, so now in the onboarding we will have the presentation layer, because the onboarding doesn't really have any domain or data, because we're not fetching data from the server, so we only have a presentation layer in this case. Alright, so we have a presentation layer that will contain views. Then finally within the views we have the onboarding. Nice, so this is it: source, onboarding, presentation, feature. So it's the source and then the name of the feature, in this case onboarding, and then finally we have the presentation, and then that is the name of the layer, the architectural layer. Now after that we finally have the view. Right, so that is how it usually is arranged. We will also have those for domains as well, so it will be the source still in the same onboarding. If the onboarding had a domain, it would live inside the onboarding directory, and then we have the domain layer in the form of a directory, and then we have the other subdirectories in there, and that is it. That's basically how it works. Alright, so moving on, we can go over to our onboarding and start building out the onboarding. Now the onboarding is quite simple, right? So we have two onboarding pages and we want to navigate between both of them. Now for that we're going to use a page view. So let's start this out. So it will be a first of all import material. Now it's going to be a stateful widget. Why? Because I have to store my page controller. If you're using hooks, you probably don't have to. So onboarding view. Alright, then after that we put the different pages in here, but I'm not going to do that. I only wanted a little stub. Now after this we've also got the home view, the login view, and the onboarding view, and these and also the splash screen. Right, so let's go ahead and build a stub for the login view as well. So new Dart file, and first of all we create a package, and that will go beyond. So what do we do next? Let's do the login view, so that'll be nice. So that's the new package that we're dealing with. Now in the authentication, I'm going to have both of them, two different views, and that would be the login view and the splash view. Alright, so but let's do the login view just a little bit. Now the login view import material can be a stateless widget, so that'll be the login view. Now it's going to have a path because I hate dealing with strings. If you take my tutorials before, well, I don't hate it. Hate's a strong word, but I really am weary of using strings because it's very, very easy to mess it up. Right, so strings don't get underlined with. I mean, Android Studio does IntelliJ products generally do a very great job of spotting typographical errors, but not all the time. Because sometimes if I've got something like a Pascal case error, like let's say your login it doesn't underline it, but if it was all lowercase, it knows there's no such word, so I could see the green underline that it says that. So in that case it's not quite perfect, but I really dislike dealing with strings. So instead of always calling /login, I just store it here and then put it in my router. Now over here we can have a, do you know what? I was actually thinking of leaving them as placeholders, but no. I'm going to build out a scaffold, and with an app bar, the title will be constant text. Now this text will be sign in, and then the style will be the text styles. Text styles this dot heading semibode. That is it. Now it will have a bottom part that draws a grey line across the screen, and we see that on, I believe, every single page when we look at the user interface. So I'm going to put that part in the core folder because it's common throughout the application. So I'm going to go over to the core folder in the common, in the widgets, create a new widgets folder, widgets / app bar bottom, the bottom grey line. It's going to be quite simple. So import material and then stateless widget. So it's going to be app bar bottom, right? Now over here, when we try to put in a bottom for the app bar, you can see it's a preferred size widget. So we're also going to deal with it the same way we deal with abstracting an app bar itself. So it's going to be with, sorry, not with, implements preferred size widgets. Nice. And then we override the height, and we go ahead and use the size.0 because we're not using the app bar height because we've already got an app bar. We just want a single grey line running on the bottom of every app bar. So if you've found a better way to do this, you could go ahead and, yes, preferred size. Now the preferred size will be this, and then the child will simply be a colored box whose color will be adaptive. So if we're in light mode, it's going to turn white, very white, and then if we're in dark mode, it's going to turn a little dark. So in light mode we use colors.white, and in dark mode we use colors dot, I think it was dark theme, this sharp color. Now we're going to run this and see how it looks, alright? But for now, just stick with me. Alright, so we head over to the login view, and the bottom we have the app bar bottom. Nice, and then finally we've got the body, and that will live right here. Now for the body, I'm actually using a placeholder. Alright, so that will be a different implementation altogether. Constant. Nice. Now finally we could build the splash screen, and that would be still in the views, new Dart file, splash. Material also, stateful widget, because we're going to be making calls to the server, and it'll be the splash. Now after this I've got a scaffold, and after the scaffold I've got a background color, which colors dot light theme primary color, which is the light purple. This is what I want, both for dark mode and light mode. And then after that we have the body. Now the body will simply be the eComly logo, which I will use over and over across the application, because I've seen the eComly logo across different parts of the user interface of the UI design that we have. So I'm going to create a separate widget for that, and that will be the eComly widget. Now this logo will simply live in the we already had a widget, so over here, Dart file, I'm going to call this eComly. Right, so the same way Flutter has its own logo, you could totally call this eComly logo, whatever, but I'm going to import material, I'm going to create the logo. Do you know what, let's do right by ourselves and call it an eComly logo. Alright, so in here, the eComly logo will simply use, we could actually take a text style for it, because we're going to be constructing this from scratch. So text style, I want it to be variable, because on different pages the eComly logo is either big or small. For example, in the splash screen it will be super huge because it's the only thing in the center of the screen. So I'm using a text.rich, a rich text. You could also use the proper rich text, and I'm going to pass it a text span, which is a text that says ecom. Right, now the ecom will have a style of the style. If the style is null, it will be text styles dot app logo. Now this is a text style, but it doesn't have a color, so I actually wanted to write an extension for text styles, right? So to extend on text styles so that I can literally use a dot notation to pass a color or to modify the color of any text style at all. So in order to do that, we're going to have to go over to our extensions and create a new one called new Dart file text style extensions .dart. Alright, cancel. Perfect. Now the text style extension will contain a few colors that we will use, or usually I've seen across the application being used on text. Alright, so now this will be an extension, text style ext on text style. Now text style will return the entire text style get orange, will be copy width. So that is this dot copy width, but we don't use this because it's useless, because yeah, it already knows what you're referencing. So text style, I'm sorry, I haven't imported. It'll be Dart. Let's use material. Now this will be color, will be colors dot. I think orange was light theme secondary. Yes, light theme secondary color. So it would be that light theme secondary color, and so forth. So I'm going to just do the rest of them, including the adaptive color, and we can generally just move on to our splash screen. And sorry, not here, the eComly logo, and I can dot white, and that references the white that we've got in from the extensions. Now moving on, we can pass it in some children constant text span, and it will be text ly, the eComly. So then the style of the text will be text style color, will be colors dot light theme secondary color. So we want the second bit to be orange, light theme secondary color. Nice. All right. So let's run this code and see what we've done so far. Ecomly logo. Nice. Let's simply run this and see what we've done so far. So for the router.main over here for the initial route, I'm actually just gonna wait. Typo. Builder will be that. And whatever else you've got to give, I don't care. And we return a. Let's do the splash screen then. Alright, let's see what that looks like. So I'm running this on Linux because I don't have a phone connected for now. Alright, so remember that we've enabled debug logs. This is it. This is the debug thingy. Now we can see that that's rendered over there. We could go back to the splash screen and definitely center the Ecomly logo. That's a lot. Oh, sorry. Misclick. And that's the center. That should perfectly center it, so we can see what we've built. The ecom was white and the ly was orange. Now moving on, let's see what the onboarding. We don't have to see it, but let's see what the app bar bottom looks like. The reason why I'm not showing you the onboarding is because it's basically empty at the moment, so it's just the page view which is literally empty. So let's see what the login view looks like. We're changing this to be the login view, and we can do a restart, and hopefully we get pushed to login view. Alright, so it's still got a placeholder. I can literally just put a container. Oops, daisies. Alright. Alright, so we can't see the app bar bottom at the moment. Looking back, we can notice there's no proper size to this because we've set the page size of the bar to 0. So what we could do would be to where are you? And right here. Right, so the child of the colored box could be constant sized box with a height of 1 and the width of double dot max finite. Now that is it. I'm going to switch to the light mode so we can see what it looks like in the light mode. Here you are. It looks beautiful, so let's move on. Now, before the actual implementation goes off, before the actual logic for routing goes off, close other tabs, not perfect. So I'm going to have to create the home view, but not particularly home view because we're not dealing directly with home view, because we've got a dashboard of some sort that contains a nav bar and the drawer and whatever else we need. So we've got, say for example, this is the persistent dashboard. All of this framing that we see, it always stays the same no matter what happens over here. So depending on the navigation rail or the navigation bar at the bottom, this changes, right? So this is the dynamic part. So this will contain the home view, the product view, whatever view that you've got to select from this bit. I'm using my Android Studio IDE as an example, but that is exactly what we're building in our mobile application. So we've got a dynamic view, and that view will contain the home, products, blah blah blah. But this part being the main part, I'd call it the dashboard itself. So the dashboard contains the rails or the bars and the drawers if there's any end drawer. So that is the part we're going to build. The rest of the dynamic part we're not really building at the moment. So let's go ahead and in here in the source folder, because that's where every important thing goes, we build a Dart file, and that would dashboard presentation views, and that would be dashboard. I'm going to call this a screen because it's the main screen that houses the dashboard, but the things that live in it will be views. So this bit I call them views, and then the main independent views I call them screens. Now based on that logic, I will actually how to change the independent views to screens, and you can totally leave them as they are, but this is just my little quirk. Alright, also change their names as well, so login screen, and you, my friend, would be an onboarding view. Nice. Alright, that said, we're moving over to the dashboard. So this is how the entire logic for shell routing works. So over here, let's first start off with the logic for shell routing in the router itself, so that way you understand the dependencies that I'm going to take in dashboard, because dashboard is the embodiment of the shell router, but we've got the configurations to do first before we come in here. Alright, so let's go ahead and see how that works. So going back to the router, this is so slow. Alright, yeah, so going back to the router, we've got not a go route, but a shell route. Right, so shell routes are also like go route. They've only got a little difference, which we're going to see pretty soon. Alright, so over here we pass all routes that can live within the dashboard. So if over here we've got a file detail view or file content view, which shows us the contents of a file that has been selected. Over in the shell route we put in the file detail view or file content view. If we've also got other things that can appear here, if the Flutter inspector takes over this page, we can also put that in the route section, so meaning everything that's nested inside of the main shell route. Now it's a shell, meaning it contains a shell, an outer shell, and inside of it there's something in it. So like the same thing that animals that have got shells do. It's just like a snail, for example. A snail's got a shell, the same behavior, right? So inside of it's the mushy bit, the mushy content, and outside of it is a hard shell that never changes. But the inside of it can change from a hollowed to a filled shell. Alright, so when the snail is out of its shell, it's hollowed out. But when it goes back inside, there's something in there, there's something present in it. So this is the same thing that we do, so it's why it's called a shell route, because there's one constant view, which is a dashboard that contains all of that navigation. Then we have the mushy inside, so these will live inside. The mushy inside will be the route. I'm going to make that a constant for now so it stops screaming at me, and then because I'm not going to fill that in at the moment. And then we have a builder, the same as that. Now the builder will contain a context, a state, and a child. Now the child is any of these which has been visited. Right, so let's say over here we had a home screen, we have a product screen. Now any point in our application when we push to home screen, it will still go back. It will first of all go here to the shell route where the dashboard lives, and then display a dashboard. Then the child of the dashboard will become the routes that's been pushed to. Now these routes will be go routes, and they will have their route, so we can literally push them, like quite literally the same way we push to other routes. So when you do that, the selected or the pushed route will become the child of the shell route. Alright, so we don't have to push to dashboard, we can directly push to a sub route in the shell route. So we can directly push to home or directly push to product screen, but so far as they're nested in a shell route, the navigator will literally push us first to the shell, the dashboard in this case, and then pass us a child which tells us which page it's displaying. So we can take that child, the dashboard, and also take the state, because these things will help us in deciding what to do or how to display stuff. Alright, so we've got the dashboard screen, which we haven't built yet. So st-less, it could be used st-full, don't know. Dashboard screen. It doesn't need a path because it's a shell. So yeah, port material. dashboard screen, and the dashboard screen can take a state, which will be the state, and a child, which will be the child. All right, and then it will contain routes that be pushed through. So this is all you need to do, really. All right, pass it the state and the child, and whatever happens, it will receive it. So the dashboard, whenever it gets pushed, we want to receive a final go router state, and final widget child. The child, the route has been pushed. So that's how it works. And then finally, this.state, nice. Alright, so this is basically it, and then over here we can create a scaffold with, let's say, the key. We can create a scaffold key. We could actually, in the presentation, new package, and we have utilities. So each presentation layer can have its presentation utilities. For example, in this case, we have some utilities that will be needed across the entire dashboard, and so we create a dashboard utility container to host them. All right, so where is it? New Dart file. No. It's silly. Created in the wrong place. Should be directly new package. It should be in presentation. So utils. Nice. Yes, that's better. All right. So new Dart file will be dashboard utils, and over here we've got a dashboard utilities class. So let's make it abstract. Class dashboard utils, make it a constant dashboard utils, but we're never going to use it, so then it's static. So static final scaffold key, because we're going to use this scaffold key in a lot of places. All right, so this is why I'm making it globally visible. So scaffold state, this is our way of declaring globals without making them absolutely global. This is global for every dashboard utility over here. All right, so now we can pass it a scaffold key. All right, dashboard utils dot scaffold key. Now with that scaffold key, we can open any drawers that exist here, because there won't be any widgets in here that have have access to the scaffold key if we saved it in the state of this application. I'm totally even going to convert this into a stateless widget. Alright, so stateless widget, because there's no point to making it stateful, I don't think. Alright, so any other widget that needs to use a scaffold key will literally reference the dashboard utils.scaffold, and that would give them a scaffold key. Now the child of the scaffold will always be the child we've got from the router, and that is how, the body, not the child of scaffold, use bodies. I totally forgot about that, so sorry. And then finally we can build the bottom nav bar and the rest of them. We're not going to do that, not at the very moment. So let's go back to, because we're focused on routing at the moment and not building screens. Alright, so we can go back to our router main, and in here we can then put in the logic for the initial route. Now over here we have the cache helper, which should be cache helper, but over here we don't have any way to inject the shared preferences into the cache helper, because it needs preferences as dependency. Now we can't do the shared preferences.get instance because it's a future, and we would have to wait it, but we can't mark the function as an async function. It will error out. You can see argument future cannot be assigned to a widget function. Right, so we can't do that here, so I'm going to have to introduce just a little bit the dependency injection. We're going to go into more details later down the line of this tutorial, but for now I'm not teaching you dependency injection in the context of clean architecture. We're just doing dependency injection for the cache helper. Alright, so the first thing I'm going to do would be to install getit, because we're using getit for dependency injection in this course. So that would be Flutter pub add getit and Flutter pub get. Now similarly to what I've done with the router main, I'm also going to do the same with the injection container. This is where all the injection goes on, meaning there will be a lot of files going through there. So that will be injection container .dart, and we also will have the injection container .main new Dart file. And that would be injection container .main. All right, so the main file will always be part of the normal files container.dart. All right, and then moving on, we've got the actual file which will be part injection container main.dart. All right, so in here we can initialize the injector, the service locator SL. Final SL will be equal to getIt dot instance. All right, and then finally we have a future void, because it's future, because we want to be able to await. So async, and we initialize await. Final prefs will be equal to shared preferences dot get instance, and after that we can service locator dot register. We want a singleton. We all know what a singleton is at this point, and then we inject the preferences. So dot prefs. All right. So and then finally we have to go into the main and call init right here before the thing starts. So we change this one to a future void async and widgets flutter binding dot ensure initialize, and then we await the initialization of all of our dependencies. So this is how it would totally work, the flow of dependency, but not teaching you dependency injection yet. So hold on for a bit, don't start screaming at me yet. Now, part of the injection container, oh sorry, what am I doing? Part of the router, not the injection container. Now, part of the router will then use the service locator to find any cache helper that has been injected into the dependency, that's been registered into the service locator. That will be a cache helper, is what we're looking for. Cache helper, nice. So, oh, well, I don't think I've done that properly. So yes, so sorry about that. This is what I was supposed to do rather. I was supposed to cache helper with SL shared preferences, because that is exactly what I've registered. Now I could do it this way, which is a bit longer, but I don't want to have to do this over and over. If possible, we could literally have just a singleton for the cache helper itself, which integrates the cache helper. So we could go ahead and do that, and rather than using this, we can first of all, so we can spread that, and we can now we can also keep this as a singleton, so register lazy singleton, and that will be a cache helper, and it's looking for a preference which we've already registered in the service locator. So we're going to say when you're looking for a preference, check in the service locator registry, where we're pretty certain that we've registered something like that before, which we've done here. Alright, so it's going to find that and inject it to itself. So that way we don't have to do this, we have to do this rather, cache helper, and it will find us already registered and ready to go, ready-made cache helper for us. Alright, so now we can focus on writing our logic. So over here, after we instantiate the cache helper, we don't just want to do that, we want to also get the session token and get the user ID. We have to invoke the functions to do that. Now, implicitly, these functions will register the result in our cache instance, our local copy, a very, very live copy. I hate calling it local because it's not very local. Local would be from the user's device, but this is a live copy that we're looking at. All right, so now over in the builder, all we're concerned about is if the cache helper dot is first time is not true, is true rather, like is the first time we push them onboarding screen, right? We push them to the onboarding. if it's not their first time, what do? We push them to the splash screen. Now the splash screen will take care of other things like using the token to verify if they're still valid. If they're not valid, it pushes them back to the login page. And if they're valid, it fetches their data and pushes them directly to the dashboard. All of that logic happens at the splash screen, which we're going to see later when we're into implementations. But for now, like I said, we're still doing routing, so we're going to focus on this. So this is how it's going to work. Now, what about over here, detecting if their session is available, right? So if there's no token, or the token doesn't exist yet, and it's not their first time, because in this case we're very certain that is their first time, yeah. But what if it's not their first time, but the token is not available, or something's happened and it's disappeared? We have to push them or redirect them directly to the login page from here without having to push them to splash screen first, since we already know the token doesn't exist. So the only moment or the only time we push them to the splash screen is when we're pretty certain that we have a token to work with, right? So it's, if you catch my drift. So moving on, in that case, if there's nothing to work with, we redirect. Now as a redirect, that redirects them, right? It redirects them to a different path. Paul, why can't we do that in here in the same builder? Why can't we just check that in here and push them there? Because if we do that, the path will still remain the initial route. So if we're pushing them to login, it will still remain / and not / login, right? So we want the entire path to change, so we use a redirect, because a redirect lets us return a path and not just a widget. So the widget onboarding will still be /, which is quite accurate, because / meaning initial route can still be the onboarding. The splash screen is still the initial route. The home page is still the initial route. So these things are still under the initial route, but when we're pushing them to login, even when we're doing that in the splash screen, we push them to, you already know what I'm going to say, login. Alright, so for that reason, we also have to register the login. So go route. Let's use the login. I told you I don't like working with strings. So login screen.path will be the path, and the builder will be the context, and the state, which I'm never going to use. So underscore double underscore goes to constant login screen. Alright, and that's it. Nice. Now over here in the redirect, like I told you, let's us do that. So context, it lets us return a path instead of a widget. Now the final cache output, because we don't have access to it, so I'm just copying that over and reinitializing it. So this one runs before the builder. Alright, so it checks if it needs to redirect before it actually builds. So the builder assumes that you actually want to go to the initial route, so it's gonna do some logic and then push a widget depending, but still under the initial route. But redirect run first because it assumes that you want to change based on some logic. So I'm going to put this in a double parenthesis, right? So in this case, we've run the cache output.get session token, and we're pretty certain, yeah, that we're pretty certain that this get session token has registered it in the cache, and the live cache that we've got, and a live cache version that we've got. I don't like calling it a local cache, because the local cache in my brains refer to the user's device. Alright, so but in this case we use a cache dot instance dot session token. Now if a session token is equal to null, or the cache dot instance dot user ID is equal to null. And the cache helper dot is first time is not true, meaning they're not first timers, but these values are null. We want to take them login screen dot path to the login screen, meaning redirect here. Alright, so meaning the route will also change if we're viewing it on Flutter Web. or using it as a website. So this routing will also remain if you're building a website out of this, so you don't have to worry. Now that is condition 1 of our redirecting. Now there's a different scenario where we also want to redirect. Alright, so now after checking in the splash screen the validity of a token and verifying that it's still valid, or fetching a new version and validating them, we want to push them back to the home page. Now the home page lives under the dashboard routes. Alright, so we directly, remember, we don't push to a shell route, we push to a sub route in the shell route, and it will push the dashboard and then it will push the dashboard as a wrapper around the thing that we're trying to push and pass a child to it. Alright, so that said, enough yapping. Right, so that said, after the splash screen's done its validation and whatnot, we want to be able, not only from the splash screen but from other screens as well, we want to be able to push to the / route, the initial route, and it should be able to sort it out and know whether to go home or where else to go to. Alright, so this is basic logic in web. I'm bringing web logic in here. We usually will be able to push to / the initial route, and it will take us home where we want to be instead of taking us to login. So we want all of that logic to still live in here. So when is it going to take us to home? If the person who pushed passed an extra, because the router, when we're using it, so that would be go router dot off context and then dot go. Now we can pass in an extra after passing the route. Now that extra, we can pass in the word home to it. Now if the extra is equal to home, right, we can return the home view.path. Right, we don't have a home view yet, so I'm simply going to create a home view. So that would be new Dart file home.presentation. No, that's a / I'm not creating a package. Presentation /view /home view. Alright. And that would be import material and a stateless widget, which could change to a stateful widget anytime soon. Alright, and then the path, static constant path, will be equal to / home, and that is it. Boom. Home view.path. And this is it, taking us to the home view. And then if any of these is not the case, then we return null, meaning don't redirect, take them to the builder. So when it's null, it directly goes to the builder and tries to build out the page. This is the routing logic. It's a bit complex, but it's nothing too difficult for you lot. You lot are pretty smart. I know you are, so trust me, you'll get it. Alright, so over time we're going to do this over and over and over again, so don't worry about it, you get enough practice with it. Alright, so I'm also going to try and reiterate on certain things. Alright, don't worry. Alright, so that's it for routing. Let's move on to other important things. We already had a little stub for the onboarding, so I've literally run the app one more time, but I'm getting that error. So we can go into the router main, and I've left that route empty, and we're not allowed to do that. So we've already got a home view with a path, so I'm going to register that. That's going to be the go route path as a home view path. Beautiful. And its builder returns us a home view. And we do a restart, and that should work now. Still doesn't work. Alright, so I quite rightly called or created an instance of shared preference, but I never awaited it. I never awaited that, so it was getting a future over there. Alright, so now that's it. So hopefully we're on the onboarding. Hopefully. Where are we? Setting location for /. I know we're in the onboarding, so let's test that claim. Yes, we're only onboarding. So over here, we already had the page view, but we need two different pages with two images that we had in the assets. So let's build a separate widget because these pages are literally the same, just with different properties. Dart file, the same properties but with different values, and that would be onboarding info section. So that will be the onboarding, sorry, import material. Onboarding info section. Now over here, I'm actually going to split it into two different parts because I already know what to use. Like, it's not dynamic. We're not fetching data from a server or expecting data from the user. It all comes from us. The onboarding depends on us. So it's basically hard coded. So for that, I'm using named constructors to construct both first and second onboarding sections, and both of them, in order to know whether it's the first or the second, we have a ball that says first, and finally over here we do this for first will be equal to true for the first, but first will be equal to false for the second. Alright, so then over here we can dynamically return stack, and I'm going to set its clip behavior to none. And finally alignment. Let's do center. And the children would be image.asset. We already registered them in the media, so if it's the first page, we use media dot onboarding. Female was the first one. Else we use media dot onboarding male. All right. Finally, the column. But before we move on, let's register. All right. That goes in here, and we have onboarding info section dot first, and finally the same thing but with the second. All right. Nice. So that's it. This column will contain, first of all, the main axis alignment will be space between. Finally, we've got the children. This is going to be if this is a first. We have text. Do you know what? If first is true, we're using a switch expression for that. So over here, instead of a container, we'll return a rich text. It could be rich text or text.rich. I don't have the energy for the long form of the rich text, so this will be a text span. Now the text to this will be the date time. It takes a text, so date time dot now dot year dot toString. We want the year of it, and then we append that. This will automatically do the string interpolation for me, so I can hover over that and replace it with interpolation. There's a quicker way to do it. And then style will be text styles dot heading bold, and we want the color to be orange. Nice. 2024 is the year. The children will be, give me a bit. Nice. So the children will be a text span with text saying winter sale is live now. Now the style of the text will change, it becomes a text style with a color being alright. So looking at both the dark and the light modes of the user interface on Figma, the color should actually be adaptive, so it changes based. I think I'll put that in colors dot adaptive, classic adaptive text color. Alright, so that is it. And that should be that for you. When we remove that text alignment, it still remains the same because I believe that is the default for the Flutter text widget, but you never know, so I always put it in there for you never know when things change. So Flutter could literally decide to change the default and then your UI crashes on people's devices. Text.rich goes to text align with left again, and the text span will be with text that says flash, and with style heading bold, and we want to copy with, or let's use the adaptive color. Yes, nice. And then it's the children, and that goes right after the style. The children will simply be a few text spans with text saying men's. The style will be text style with color being orange. Secondary text color, that's the orange color. No. Our second bit, let's use the ampersand according to the UI. Shirts and watches, and that would be style color. I believe that comes from the colors classic adaptive text color. Alright, so this is the first onboarding. You can't see the second onboarding because I'm on desktop and there's no tricky. So in order to see the second part, we can swap them and do a restart. Nice. Now this is the second bit. We can already see there's a flaw. The men's shirt is horribly put. Alright, so just add a little bit of space either there or there, and that is it. So we're moving on to the architecture, writing the domain data and the rest of them, the authentication. Let's say we've got a phone. That is an ugly mobile phone. Now this is a mobile phone, it looks like a smiley face, don't mind it, I'm gonna add that. Still looks like a person's face, but we're gonna ignore that and get to the point. Now we've got that phone and we've got a server somewhere here, right? The server sits here, right? And the server talks to a database. The database is sat here, and so there's that communication from there to there and from there to there. Now, in order for this communication to happen, this sends a request to that person. This server sends it over to the database, queries the database, and gets a response back. So the response flows from that person back to this person, and from that person back to this person. Alright, so we've got a two-way communication, sending and receiving. Now, in order for this to happen, this communication flows this way, and on its way back, it has two types. Now, it can either return a successful state, or it could return a failure state, or what we know as exceptions. So in the server, we already wrote the nodejs code, and when we wrote that, we usually sent a response.json for which they just go 200 or 204 or 201, whatever is in the 200 for OK requests, meaning success. Whatever you wanted to do happened successfully. Now we actually sent other types of responses ranging from 400s to 500. The 4s to the 5s, these are the failures. This is a success. Now we've got two types of requests, two types of responses, response 1 and response 2. So these are the failures and these are the successes. Two states are come together and form a response object, in which is what we receive in the Dart client and the Flutter client when we receive the response. Now, since it's got two types, we usually deal with this normally. Send it over to the serializer if we've got a serializer, or if it's a single return value like a bool or a string, and we don't have to deserialize it, we directly send it over to the presentation layer or to the UI to be displayed. Now, when it's a 2, we usually catch it in Flutter in the form of an exception, right? So exceptions usually in the catch block E. So when you catch an an exception is something we call a throwable. It's throwable. You can throw it, right? You can yeet for the Gen Zs in the corner. You can yeet the exception. All right. So since exceptions are throwable, it means they crash the application, they throw or yeet the user out of the application. So your application crashes, you're thrown out of the application. You either see a red screen or the application totally shuts down. In Flutter, we usually see a red screen, and then the console, you see a lot of red, or just a memory, an error log, a stack trace. Just your console throws up pukes all over your computer, and you see all that information, and you have to find where the issue comes from. So we call that a throwable. It throws you out of the system that you're running, because an application is simply a system that collects events, processes them, and gives the user a response. So that system is thrown, it's crashed. Both the developer and the user are thrown out of the system. Right, so that's enough of explanations for why it's throwable. Now, that aside, we don't want that behavior in a production application. We don't want the user to see an ugly throw, or to get thrown out of a loop or out of the ongoing thread, whatever's going on at the moment. We don't want to throw them out of that. We want that to keep its state. We want the entire user interface to remain the same, but then we alert them to the failure that has happened. Right, so notice how I'm not calling it an exception. I'm saying the users see a failure. They know something has failed, but they're not thrown out with an exception. So how we handle this in the clean architecture, or in the way that I'd handle it, or the way that you usually handle it when writing production ready applications, is to get the exception, catch the exception. Right, we catch the exception when we talk to the server. That would be in the remote data source. Don't worry about that. We're going to see that in its totality, so you don't have to worry about it. Now we catch the exception, right, and we throw the exception to our console by printing, or however you want it. Right, you can send it over to a server, or you can log it to a file. However you wish to do that doesn't concern me. Right, now after we do this, we actually convert this exception into a Dart object. Right, and a Dart object, we will call that a failure. So it's simply a Dart object that contains the message of the exception. Right, it's not throwable. It's just a normal object. All right, so the presentation layer receives this, or it receives a success. So presentation layer expects either a success or a failure. Either way, it never throws. All right, so if it's success, it displays a success in the UI, and if it's a failure, it also displays a failure in the UI. All right, so we convert this dangerous live grenade, we convert it to that, so it becomes safe, nice, pleasant to look at, it turns into a snack bar or whatever you want to turn it into, but we get it through this object called a failure. So this is what we're going to be seeing in the code. We get exceptions, we convert them to failures, we get successes, we also return the successes. Either way, we return or we expect one object, one Dart object, either this or that. Remember that word, either. Alright, so let's get into the code. Alright, so we're back in the code and we're going to practice all of that using the authentication layer, because the authentication layer is the very first thing that we all see. Now, authentication's more or less the door to your application. This is where everyone goes through in order to get into your application. Now, in here, we're going to start out with the domain layer. Alright, so that would be a new package. Instead of the presentation, it goes into the domain. Boom. Now, in the domain layer, we've got 3 other layers. If you don't remember the layers and all that, you could go ahead and watch the very first section, the very first few sections of the entire course for the Flutter part. Alright, I explained those. And over here, we're going to create, so we've got 3 different directories in the domain layer. Now, the very first sub layer in the domain layer would be the entities, which hold the contract. Now, if you remember correctly, I told you lot that the domain layer actually acts with contracts. So it defines how the feature should act, what functionalities it should possess, and it also describes what properties, what characteristics should exhibit. Now, for example, the Auth layer could have functionalities like logging in. So the Auth feature, not a layer. Alright, so the Auth feature should be able to log in, register, verify token, and the rest of them. So these are functionalities. We define these functionalities, the parameters they take, their return types, and so forth, right? But we don't actually put the implementation. It's a contract. It's what you should do. So it's telling you what you should do and not how to do it. If you get employed into a company, you're not told how to do your job most of the time. You're only told what you're required to do. Alright, if there's no senior developer, I mean, like, if, let's say it's a startup and you're being employed to create a Flutter application, pattern to the Figma design that was handed over to you, you're not told how to write the Flutter code. You're not. You're only told that you're required to create that user interface. So your functionality is explained. Alright? It's defined, but it's not really written for you. You do the implementation of it. So this is also what we're doing here. And this is also great, if you remember correctly, because it serves as the single independent layer in the entire architecture. Right, so the domain layer is independent of any frameworks. It's just purely Dart, and we're going to see that right now. It doesn't depend on Flutter at all. No context, nothing. Right, so in the domain layer, we've got 3 folders. The very first folder would be the repositories. I'm going to write it in full, but you can just simply write repos. But for this very first feature, I'm actually going to write it in full. So repositories. Now, the second package, or the second directory, would be the entities. Now, repositories contain the functionalities. What can this feature do? The entities contain the return types of the repositories. Alright, so the repository functions. So if we've got login, for example, a login feature or a login functionality returns a user object. Alright, so we know that the server will give us the data of the user, and over in Dart we want to change that data from the server into a user object, and so that user object will become an entity that we put here. Alright, we define that schema over there. So that is the function of the entities. Now it will be a last package or a last directory called, no, that still lives in the domain, and it's called the use cases. Alright, so in here we've got I've already explained these two, but we've also got the use cases. What are the use cases? The use cases are the only thing that connects these functions that live in there, the contracts that live in there, with the rest of the layers, and we're going to see how that works. All right. So in the presentation layer wants to depend on the data from the server, but the data from the server, its contracts have been defined here. Its implementation will be defined in the data layer, but then how does the domain connect to the data? We do that through use cases. All right. I already taught that in the previous sections. You could go back and watch how that works. Now, through that dependence, we can also pass that same use case to the presentation, and the same use case connects to the data and finally connects that data finally to the presentation layer. Alright, so now we've got use cases, repositories, entities. We start from the entities, right? Because we're basically defining what we're returning, the return types, and without that we can't go into our repositories, because repositories want to return something. So now in here we're returning the user. Alright, so the user is the entity for the authentication, but remember that every other feature will actually also depend on the user entity. So the user entity is no longer just localized to the authentication. The user entity has, by unction of its scope, become a global, not really a global, but a core or a common feature across the board. For that reason, I'm not going to put the user entity in the auth layer, alright, auth feature, because we have the user feature as well, where we can define user functionalities like we saw in the back end. Alright, so we've got the user endpoint to get user profile, edit user profile, and the rest of them, authentication or authenticate. It's totally different things. So these two features will definitely share the user entity. Alright, so now the user entity also has their address, right? And we also have the address entity, so these two are shared between them. Now, one way we could do this would be to go into the core common, and we can create in here a new Dart file, and this will live in the entities directory. So it's a common entity dot user. Alright, so entities dot, no, what have I done? It's entities slash user, not dot. I'm so used to creating packages and not Dart files. Alright, so entities slash user. So this entities is no longer needed. Alright, so cancel. Now we've got the class user. Alright, and the user class or the user object has the following properties: final string ID, it finally has the name, final string email, final bool is admin, final I think wishlist, list of wishlist products which we're going to create later. So this is composition. So we're going to compose this object to include other things, but wishlist products, we can create a wishlist feature later down the line and put it there. But for now, I'm just going to create a wishlist product for dummy data over at the bottom of this same class. So over here, I'm going to create class wishlist products, which will do that at the bottom. We're going to change that and put it in its own feature, because we will have the wishlist feature. Alright, so now moving on, we've also got the address. I'm going to create an address which can be nullable, because according to the schema from the user.js, it was models. My models, yes I am. So alright, so we can see all of these. Alright, I'm just copying them over to this man over here. Alright, so I'm ignoring the cart, because what exactly am I doing with the cart? The cart is going to be its own feature, and I don't care. Alright, there's no UI feature or UI functionalities that depend on having the cart readily accessible at every point, but the wish list has some features that need it to be a part of the user data, because we've got those products all over the application, on the home screen and everywhere, and those products have wish lists or favorite buttons where people can click them and add them to the wish list. Now, if the wish list wasn't readily available in the global user, because this user will be set to global the moment that they log in, and you can access it from any part of the application. Now, if we didn't do this way, the other option would have been to create a separate endpoint for getting the wishlist products. Now, it means that for each product, we'd have to query the server in order to get the user's wishlist and then check if that product exists in the user's wish list, or we could totally store the wish list somewhere else, just as its own, I don't know, entity, somewhere in the application as a constant or something. But what if that changes? Then we also want to apply that change and refetch. Now that would cause a lot of querying to the server. So the best practice that I personally found was to do it this way, to store the wish list in the user as it was in the schema over here. Alright, we also don't need the reset password, OTPs, and blah blah blah. Now the rest of them, like country, postal code, city, street, these things actually rather go into the address. So the address will be its own object. Alright, so now moving on, we've also got final string phone. If your e-commerce app has some UI features that depend on the payments and the customer's payment ID, which I don't think we need on the UI because on the client, because this is probably more an admin stuff where the admin can finally open a user's data in the database or in their admin panel and see their customer ID and use that to check their transactions and whatnot. Or even querying stuff on the back end, we can totally send over the user ID and the back end will find the user with that ID and then check for their customer ID over in the server and do all of that on the server. So there's no reason to put that on the client. Alright, so that's it. Now we all know about how Dart's equality is some sort of referential equality, but we want value equality because we don't want two objects to be the same only if they're pointing to the same address in memory. Alright, if you don't understand what I'm talking about, you can go ahead and read it up on Google, but that's not what we're here to explain. Now, you could totally go ahead and override the bool equal to operator and go ahead and write the hash code and the rest of it. But I'm not going to do that. I'm simply going to depend on a package called the equatable package, which does exactly what it sounds like. Flutter pull-add equatable and Flutter pull get. I don't know if I've previously added the package. Does it already exist? No, it didn't. Equatable, yes. So it's been added. Right. Did I Flutter pop get? I definitely did. Alright, so now how to use equatable is quite straightforward. You can go ahead and read the documentations, but you simply have to extend any object of the equatable, and finally, let's see, we can add one missing override. So you override the properties of a class that you want to use for value equality. For me, I don't always use all of them. Alright, I only use the ID mostly because the ID is good enough to identify two different users. Alright, so if I match this user against that user, I believe the ID that I get from my server is actually unique enough, or from the MongoDB is unique enough to differentiate between two users. Alright, now that said, for testing purposes, we're not going to be doing testing on this tutorial, but for testing purposes, I personally add these. If you've watched my other tutorial on unit tests and all that, for me, I add all of them for when I've got a list. Alright, when I've got a list, I usually use the length of the list instead of spreading the entire list in there. Alright, or adding the entire list as something to be equated. So personally, I just use the length of the list. Alright, so now the only thing left would be the constructor. So constant, let's just generate that. A named argument constructor with all the properties, and we move that over to the top. All right. We don't have to do that. It's just my personal preferences. Now, for testing purposes, again, if you've watched the testing tutorial, you know what I'm talking about. If you haven't, and you already know how to test, to do unit tests, you also should probably know what I'm talking about. So when testing, you usually need to mock a user or to get maybe a version of an object. To get an instance of an object, you don't have to start passing dummy data every single time. You can do that in here by creating the dummy data over here. I usually give it an empty constructor, so that way in a test I can simply say final test user will be equal to user.empty, and it gives me the dummy data. So I already registered the dummy data over here as part of the object. Now the ID will simply be, I'm going to put this as test string, and I'm going to do the same for all of them. Alright, I've done the same for all of them. And for the ones that were nullable, I usually pass them as null, and for wishlist, I've put it as a constant empty list. The admin is set to true by default as a dummy data, not by default. It's dummy data essentially. Now the address would be, I think I've spelled it wrongly. Entities. Refactor, rename it. That goes to entities. Right, alright, I totally butchered that one. Alright, so the user.dart is done. Now we need the address.dart, and that goes into address. Alright, so now the address, well, I'm simply going to do the same thing, but I'm going to do the same thing and cut you into the video when I'm done. Alright, so I've done everything the same way, but with some extra details. So over here I've got a getter to tell me if the address is empty. That will be the case if everything is null. Alright, so if they're street, apartment, city, postal code, and we know that they've got an empty address. Alright, so if address.isEmpty is true, we know that, and then we could also bool, I don't think this is necessary, address is not empty, or return the opposite of is empty. I don't think we're ever going to use this in the user interface, but I only think this is enough. I believe that will suffice. Now that said, we're done with the models. Now over here we can totally add the address model. We can go back to the repository. Now over here in the Auth repository, we could create a file called Auth repository. Now you could call this Auth repo, which I always do, but in the spirit of tutorials, I'm actually going to call it, or write it in full. So an interface or a contract is supposed to define the structure of something, how something should function, what you're supposed to give to the company, and what the company will give to you. So your inputs and your outputs. Alright, so it's telling you you're expected to work 10 hours a day. I don't know who works 10 hours a day, but you're expected to work 10 hours a day, and we give you computer, internet, and whatever you need. Alright, now in that case, they don't define how you do your work. They don't define how you give the 10-hour output, or how you give them a function application at the end of the day. They don't care about that. All they care about is a contract that has been given to you. Now, contracts do not come with implementation. Like I said, they don't have a body. There's no command telling you must write this particular line of code or that particular line of code. No, all of that comes from you later after you've accepted the contract. Now, in order to define a function or to define functionality and tell it its output and its input without giving it explicit implementation details, we tend to use abstract classes in Dart. If you're coming from Java, you're used to interfaces. Interfaces is the correct programming term for a contract in programming generally. Now, so Java's done that right, but in Dart we use abstract keyword in order to make a class able to do that, or in order to convert a class to a contract or a proper interface. We have the interface keyword in Dart, but it doesn't let us do interface things, the proper interface things, like declaring a class without a body. Alright, so let's do the abstract class auth repo repository, as you love me to put. Now I'm going to give it a constructor auth repository. I just love having constant constructors. Now over here we could have, let's say for example, if we had a future void, alright, the future void register. Now the register function should not have a body. It will take inputs, alright, so the company is expecting you to return void at the end of the day. That is 0 hours, and they're giving you the name of the person, their password, they're giving you internet, food, a resting place, giving you a car. Yes, so they're giving you all of these, and they're expecting 0 hours at the end of the day. Now, in order to do this, you can see there's no syntax errors, meaning I've defined the contract without any explicit implementations. Alright, so this is a contract, and it works. It works this way. So if I decided to change this to an interface, you'd see it throws. Alright, so it says register must have a method body, because auth repository isn't abstract, so it's not abstract, so it can't be a contract. Alright, so either give it a body or turn it into an abstract class, and I'm simply going to turn that back into an abstract class because that's how we row. So moving on, we've done that. That is how a contract works everywhere. Now moving on, we've got quite a few other contracts. Future, this one returns a user, and it's the login functionality. Now the login functionality gives us string email and required string password. Now we've got quite a few more. You can find out your functionalities for any given feature by your Postman collection. So for example, these are my functionalities for the auth. I taught you how to create these, if you remember. So I'd have login, register, forgot password, verify, password reset, and reset password. These will all be functions or contract functionalities in the feature for the authentication. If you don't have that, if you don't have a Postman to look at, you could go back to your thingy. Over here we've got auth, for example, in our not here, in the routes. Yeah, so we've got auth, and over here we can see the functions that the routes of the thing. So you can convert these routes into functions in your Flutter application. And then how about the things that the route, sorry, not the route, the things that the function accepts and what it returns. Now we can go back and see in the proper implementation, say for example for login, you can see that the login, why have I got this open? So the login, close this down as well. The login, where is it? Where is it? There you are. It returns an object that gives us the user's information. Now that's how we know that it returns a user. Now we also know that it expects email and password from the body. Now that's how you get the input over here. Alright, so you get the input either from the request body when you see what it's expecting from the request. So when you find out every request, every rec dot something. Alright, so rec dot, if it's got rec dot params dot email, you know you're expecting email. If it's got rec dot query parameters, you know it's expecting a query parameter of email. All of those, including the body, will become the input in your function. So I'm telling you how to convert these into functions over here. Now over here it's a lot easier because we've already done it. You can see that the body exists, and the body contains email and password. Those become inputs, and the output becomes the output, you know. And we also have sometimes query parameters, and query parameters, all parameters, path parameters, become also inputs, and that's how it works basically. So all of those will become an input. Find the recs and find the returns. Now moving on, let's import the user And I'm simply going to create the rest of the functions as well because we don't have much time. I've sorted out all of them, but I've actually got a little issue over here. I'm simply changing these. No, that's right. I've got a little issue. Remember what I've just taught you at the start of this particular session, where the server will definitely throw an exception, and we don't want those exceptions to be returned from the data layer. By the time the data hits the repository, we don't want, because from the repository it directly goes to the use case, and we're going to see how that happens. But by the time it hits the domain layer, we don't want to have exceptions. We want to have proper Dart objects. So remember I told you you have to return either a failure or a success. So we have functional this. It's not basically everything about functional programming, but it's got that feature from functional programming where we can return two types from the same function. Now over here in Dart 3 we've got this thing called what are they called? Are they tuples? Are they? No, records. So we've got records, and records let you return either, let's say, a failure or a success. Now this is totally valid now, but in the spirit of what we've always been doing, you could totally do that. But for me personally, I still prefer the descriptive way, because this way that I'm about to show you is a lot more descriptive, readable. People know what you're talking about when they read your code. So I prefer that more clarity. Now that is all regardless of the fact that it pushes me to use a different package for it, to add a package to my list of already growing packages. Now the package that I'm going to use would be darts. Now you can also use fp dart if you want to, because it also gives you the either class, the either object. So I'm going to flutter pub add darts and flutter pub get. Alright, so now moving on, we're going to give it a bit. It's wasting my time. We're going to have to create an object which the UI or the presentation layer will be expecting, which isn't an exception. Now that object will simply be a failure, quote unquote. Now a failure will go into the, I personally prefer, you can put this anywhere that you want, but I personally prefer to put that directly in the core folder. So in here, new Dart file, that goes into errors directory, and in the errors directory we've got failures.dart. Alright, so the failures will contain several failures, not only one. So because you can have two types of failures. You can have a failure that comes from the server if you're talking to the server. You can also have a failure that comes from the cache if you're talking to the cache. So I don't think I'm using the cache failure in this tutorial, but just because of you lot, I'm going to include that as well. Alright, so we have an abstract class. I'm actually just going to make it sealed class failure extend equatable. Now we want to be able to equate failures for testing purposes. Alright, so for automated testing, always the actual secret to clean code is to write your code with testing in mind. Alright, architecture isn't like the height of it, because like I already told you, architecture can change depending on the scenario, alright, what you're dealing with. Now in such cases, you still, whether you're using MVC, MVVM and whatnot, you definitely always want to write your code like you're going to test it in mind, and that's some of the principles that I've got. So now we can formulate an error message from both the status code and the message itself. So that's error message, so that we've got a getter. Now I'm not explaining these things because I expect that I'm dealing with advanced Flutter developers. So status code error message, nice, and finally we override, and we give it a list of objects that are nullable. get props goes over to the a list, and then we give it the message and the status code. So two failures are equal if their message and their status code is the same. Alright, so now we extend. So class server failure, we've got a server failure. So that is a base failure, which we can use as a catch-all for all failures. So if we're trying to say when there's any failure at all, do this or that, we use that type. But when we're targeting the particular failure, like the server failure, we use this type. Alright, so a constant server failure will required super.message required super.status code. Now we can also do this thing where we can directly get a server failure from exception. I also love doing that. You will see that come in handy soon enough when we start converting the exceptions that we catch to failures. Alright, so that will really come in handy. Alright, so we also go ahead and we create our own server exceptions, and we don't use the normal Dart exception. Why? Just for monopoly. We want to monopolize the entire error industry. We want it all to be in our control. We want to know exactly what is going on at every point in an exception. Alright, so I'm going to create that after, but we are going to have a server exception. So created from a server exception E, and oh my, and that is going to simply return, no, I'm not in a factory constructor. It is a factory constructor of some sorts, but the syntax is quite different. And that'll be e.message, and the status code will be e.statuscode. Alright, and finally we can do the same for cache failure. You can already guess how it would look like. So I'm simply going to skip that part and show you the code after. Alright, I'm done, and I actually need to rename this to server. Alright, so server failure, and that should solve some issues, and leave the rest of them to my laziness new Dart file. Exceptions. Alright, so exceptions are simply going to class server exception, extends equatable, and implement the extension class. Exception. Now this is a constant server exception, and it's got two things: this dot message required this dot. So what I'm actually trying to do here is the server throws an exception, or sorry, our client throws an exception. Say for example we've got a syntax error or we've got a logic error and it throws an exception, and that exception will be this sort, and then we finally convert it into our sort of exception. We're going to see this a lot in the data layer. Alright, so now we get this server exception and we have final. I'm simply going to copy this. We don't need the error message because error messages get formulated over at the other bit. I'm also going to do the same thing but for cache. No, stop. Right, so the caches, like shared preferences, do not return any status code, so we don't need the status code, we only need the message. Alright, so we save that and go back over here and import our exception. So we've done some crazy monopoly on everything. So finally we can come back here, and using the darts package, which lets us return two different data types, we can convert this from a future void, alright, to an either type. You can see that already popping up from the darts package, either left or right. Now the left side will be failure most of the time, alright, so it's either a failure or it returns void because register returns void. In a case of something that returns something, we can have either failure or the thing that returns, in this case a user. Alright, so we can totally simplify this because it's a bit long, and use type definition. So I personally always put my type definitions in my core utilities. Alright, so over here I've got new Dart file type defs. Now over here I'm actually going to define some long type definitions that we use mostly in this application, and most applications I always use. So the first thing I do whenever I'm creating an application is to override or to type def the data map, which I usually use for, is a name I usually use for the map string dynamic class because it's too long to always type it. And I also type def the result future, and it takes a t, and that will be equal to the future, either, because we're pretty certain these are constants, it's either failure, which will always be either a failure, or a t, which is a type that we don't know. The t could be a user, it could also be void. Now we could go back and definitely change all of this to rather say result future, and we give it a type void, because this case it's simply going to turn into future either failure void because we've passed in void over there. Now this will change into a result future with type user. Alright, so we can just copy paste this over and over and over and over. Alright, so that's enough. Now that is it for the repositories. Now we're moving into the entities. Now the entities have already been defined, so we're just simply going to delete this version of the entities. In other features, we're actually going to use the entities. Now, what are the use cases, you might ask? Thank you for asking. Now, use cases are simply single responsibility printable classes. Alright, so these functions will each have a class. So the register will have a register object, a register class, which connects us. You can use methods for it if you wanted to, or you could use a class. I prefer to use a class because first of all we're an OOP, so that is a lot better, and it also helps with encapsulation because the class the use cases should depend on a form of the repository, which is how we indirectly inject the data layer into the domain layer. So in that case, we don't want to, it will be almost impossible, alright, to take the repository as a dependency without having to put it in every function explicitly. So we only want to provide that once, and that will be it. So in that case, a class comes in handy. So a new Dart file will be register. Now let's do this in alphabetical order. Right, so forgot password. Forgot password comes up first. Now it simply is a class. Alright, forgot password. And this class will simply depend on the this.repository, which I always love to make private because it's no one's concern how I'm doing my thing. So auth repository, we can go ahead and name this the authentication layer in full, or authentication repository, if you have such time. I personally don't know about you, so I'm also going to go ahead and call this a repo. I'm already starting to get lazy. Alright, so now over here we're going to have the same result future, which will be void. Now this will be of return type, sorry, the name of it, not the return type, the name of it would be forgot password. It takes, I believe, what does it take? Is it a string? String email, alright, string email. And we finally just simply call the repository.forgot password, and we pass it the email. Now this would totally work. You can leave this way, or if you want to actually follow convention, the convention about use cases is to make them a callable class. Remember, this isn't just any class. This is a use case, and it will be called over and over. Now, we don't always want to have to go like forgot password dot. We invoke it first, and then we go ahead and do. Sorry, let me put in a void main. So final use case will be called forgot password. Now, after we initialize this and pass it a fake version of the repository, we don't want to have to do a use case dot forgot password and then pass it an email. That is not what we want. We want it to be a callable class, meaning we can do this. We can call a reference or an instance or an object of a class, right? An instance of a class, and directly invoke that instance. In order to do that, we need to convert this to something called a call function. Now, some classes in Flutter in the framework's raw code has this call function in them. Now, when a class has a call function in it, you can actually go ahead and let me bring this back. Void main can go ahead and create an instance of a class. Final forgot password FP use case is equal to forgot password. Now, after initializing that, we can go ahead and say FP use case, and we invoke it, and then we pass it the email as a string. Right, so that would totally work. You can invoke a class's instance directly. So this is a convention. Now, again, we don't always trust ourselves as developers to always remember to name the use cases with a call function. Now, for that reason, we go ahead and we create some sort of binder on us. So we always extend a use case with this binder, and it will always force us to use a call as the name of a function. So that way, the entire class becomes invocable. Now, for that reason, I'm simply going to go over to my call, and I'm simply going to go over to my I don't think it should be in common because it's not really that sort of thing. So I'm just going to put it directly in the call folder, and it usually goes use case slash use case. Yes, always what I do, use case slash use case. Now in here, we're simply going to have an abstract class use case. Now, you could totally do this use case this way and always extend the use case over here. Let me do this. Const use case. And then we have the result feature and its type. Now, we don't know the type that the result feature will always have. So for that reason, we have to make it a type. So it will become a type, and we can take that type over at the top. Now, we also, in this case, have a use case. We always want it to be named call. We have a use case that, in this case, has params. Now, the params will be, this is the contract of a use case. So we're writing another contract. This is what a use case should look like. Always return result future with a type, with a certain type, with a call name as the name of a function in the class, and the params as the type of a param. So what does the params return? Now, params will be params as also an argument for the type. So we can then go ahead and extend use case. Alright, and the use case will expect us to tell it its type. So the type will be void, and the param type will be a string. Alright, so we have to rename email in order to follow conventions, because the name here, where is it? The name in the use case is actually params. So the params name has to match, and we also put the params over there. Now the call, it wants us to override because, as you can see, we're extending this thing over here. Alright, so now in this is how a use case looks like. However, in other use cases, like this, for example, the verified token doesn't have a param. So what do we do in that case? What do? We can't pass null for the parameter. We can't do that. And over here it will be empty. So what we usually do, what some people do, is they pass in an object type called no params. Right, no params means no parameters, and they create an object for that to always be a matcher for whenever an object doesn't have params. But me personally, I don't like that, because if it doesn't have any params, I don't even want to stress to put this there. So what I personally do is I create two types of use cases. Now I've got a use case with params, which is this type, and this will also bear the same name with that. And I have a different use case, which is use case without params. Oopsie. Without params, I know explicitly that this doesn't have any params. Now, any way is correct. You don't have to follow me. You can always follow the other bit. But for me, I just love this. Maybe I just love stress. But yeah, this is me. Thank you for watching. And then I chain this to a use case with params in this case. And it's got that and that, and I override to know why I've decided to remove the override. That was a silly malfunction. Alright, so this is what a use case looks like. It indirectly depends on the repository in the domain layer, that is. But however, when we're injecting that repository, we inject a repository from the data layer, and we do that little fake out, the footballers do the little dribble. So we dribble a little bit, and then we pass it this instead of that. We cheat him up a little bit and all that. So moving on, we've got the other use cases. So in my case, in our case, not my case, not only me, we're all in this together. In our case, we've got login, FGHI. Yeah, L comes next. Login. Now, as always, I'm going to speed through the rest of... No, I'm not going to speed through this one. This one's very important because the login has got more than one param. So how are we going to handle it? Let's see. So class login extends use case with params. It has params. Now, the type of the return type, rather, of the function or of the functionality would be the user. Alright, so this is a return type, but what is the param type? What type does the param take? Let's see what the param takes. So we've got const login, this dot underscore repository, final auth repository, and that is a repo. Now we can add an override. We can just do this, hover over it, and it creates the override for us. So that way you don't have to go through all that stress. Now, params was actually going to be whatever I tell you it's going to be soon enough. Login. For now, no spoilers. Now, remember, we want more than one parameter. Right, we want an email and a password. But we can't say params will be string email, string password. Why? Because it will throw an error. It's not a valid override of the core because it has more than one params. But we don't want more than one parameter. So what we do is, for testing's sake, this is for testability. We create a params class, just like the no params that I showed you before. We create an object for the params class for any parameter, any function that's containing more than one parameter. So meaning the type will also be login params. And over there, you can see that. You can see where I'm going with this. You can see where I'm going with this, right? Nice. Keep it up. Now we finally have class login params extends equatable. Now this will also have an empty constructor. As I always, I just literally typed empty constructor. This dot params required. This dot email. This dot password. You'll understand the reasoning behind my deleting the function. I actually wanted to show you a lot of something, so bear with me for a little bit. Now, require this dot email, require this dot password. We finally have final string email, final string password. Nice. And then we do the little override, create one missing override, and remove the to do, get list of objects, and we finally email and password. And you go ahead and you do the login params.empty, and you can do this, or you can just do the thing straight away, and its email would be equal to test string, password will be equal to test string. And we can put a constant modifier behind it. Now, if I go ahead and I create one missing override, you can see the type automatically appears. It matches because I've already put the type. But previously, over there was empty because this wasn't there. So that was the reason why I deleted this, because I wanted to flex, show off what Dart can do. Now, if I remove that and create one missing override, you can see the params is missing. So that is super cool. I'm going to be honest with you. I'm quite impressed. Quite impressed. Alright, so that's repo.login. I'm going to give it the email to be the param.email. Params.email. And the password to be params.password. See how neat and readable our code is. Now, if you're still here, congratulations, yeah, because by now I actually expect a lot of people to have dumped the course, because clean architecture is actually quite a lot to do, but again, it pays off on the long run. Alright, so also it teaches you a lot of programming concepts. Just it helps you understand a lot. So if you're not going to do it for anything else, just do it for them, for the lessons. Right, so I'm going to do the same for every other function, and I'm just simply going to walk you through it. I've already explained how params work, and when params have no params, and when these parameters have multiple parameters, and so you already get the gist of it. So I'm simply going to write all of it for you. Right, so see you when I see you. I'm back after writing a lot of code. You can see over here that I've written for the register, written for reset password, verify your OTP, and verifying the tokens. I've done everything for everyone. Alright, so that is it for the use case, and that is it for the domain layer. Now we're going to move on to the data layer, and I will see you in the data layer. That concluded the domain layer. Now, moving on, I'd like to talk about the data layer. Now, the data layer is not very different than the domain layer. The domain layer has got entities and repositories and use cases, but these things are basically contracts, as you can already see. A repository is simply a contract with no body. There's no true implementation over here. So they've only got something that I've explained to be some sort of contract, essentially. Now, these contracts will certainly need implementations. So those implementations are what we put in something called a data layer. Alright, so the data layer also lives alongside the domain and the presentation layers. So we've got a Dart file, and we have a folder or a directory called the data layer. Now the data layer contains, let's start with models. Now over in the domain layer we had use cases, repositories, and entities, right? But the entity were removed because it was a core feature. In this case, the address and the user. These were part of the entities. However, they couldn't live in here, but if they could, we'd have an entities folder directly in here. Now, what that simply means is that we can also take out the models. Now, the models is meant to be a folder, not a file. Alright, so what have I done? All right, yeah, it's meant to be a directory. All right, so we have models slash. Oh my. All right. Model slash, in this case, user dot. Now, this everything in the data layer should pattern to something in the domain layer. Remember what I've said. We've got contracts over in the domain layer. Now, in the data layer, we write the implementations of these contracts. Alright, so the very first contract we love to write, or we'd love to implement, in our case, would be the entities. Alright, the entities are simply data objects. Alright, they hold contracts of what a data should look like, for example, or what an object should look like, for example, we're telling that the user will contain phone number, address, wish list, is admin, email, name and ID. Alright, and there's no proper implementations in here. Now, there's no copy with to JSON, from JSON, and all that. There's none of that in here. Alright, so one thing we would love to do would be to implement the contract, which is the user, that just contains properties, and then we'd love to write them as models, and this model will simply be named by its entity name with a model attached to it, so user model instead of just the user. Now, given that the particular entity for the user and the address were core features, I'd also, in the same spirit, love to move the models for the authentication layer to the core, because they're also going to be very, very much so core features. So, but before we actually do that, I'd love to start with the implementation of the user model. Now, the explanation for this, again, is because we've got a contract that tells us what a user should have, but there's no proper implementation. Also, this isn't very testable, so what are we going to test? We can't test anything over here. However, the model will be the testable version of that object. Alright, so the user object, when you're trying to test it, you will not, certainly not, test the entity. You'd only test the model. Alright, so looking over in the domain layer, the only thing that we test in the domain layer would be the use cases. Alright, so the use cases are the only thing that are not a contract. There's some sort of portal, a connection of some sort to connect this over to the data layer. That's what they are. So this is basically the only way that you test your entire domain logic. Alright, so this is your portal to both testing, to the presentation layer, and also to the data layer. So the use cases are very, very important. So moving on, we'd love to write a model which includes to JSON and from JSON. Now, you could totally use freeze if you'd prefer to, or however else you generate your models if you'd love to. Personally, I love to write them all by hand because it puts me more in control of my object than generated objects, essentially. So yeah, so I'm totally going to write it all out. So it usually goes this way: user model extends the user entity. So we have the constructor. I'm not teaching Dart because, like I said, I don't expect the U lot were already Dart users. So I believe I've got some Dart experts. So I'm going to replace this with some super. Alright, replace all this with super. And then finally, we've also got the empty. In this case, user model. Also for testing purposes. Moving on, I'd also love to write a from JSON to JSON, from map to map. If you'd love to, that is it for that. I'm simply going to generate a copy with. Alright, that didn't work. So I'm going to go back to the user, generate a copy with, then cut all of that. Alright, and paste it right here. Now over here we've got an address, but we haven't imported it, so I'm importing that, and that is it essentially. Finally, we've got a to map and a from map, and I'd also love to generate those, but as you already know, it won't work because we're in a subclass. So I'm just going to close everything else, close all tabs. No. Alright, go back over here and generate both to maps and from maps, and yes. Alright. Nice. And then we paste. Now remember that the map string dynamic was already type deft, so I'm changing that to data map. Now over here we're rather returning a user model, user model dot from map. Alright, so that should solve that. We're also changing this to user model. Now, I'm not quite happy with the address because the address is going to return an address model. Right, so I'm simply going to go over to the address and create an address model quite quickly, and then come back here and create an address from the data that we get from the backend, because we all know there's no address key in the map that we get from the backend. We've only got some scattered addresses, so we're just going to collect them over here and create that from here. Alright, so also the wishlist will also have to change later on to return a wishlist product model. So I'm actually going to create a wishlist feature and also create the wishlist data and entities and models for the wishlist alone. Alright, so that way we can have the product and the product model to deal with. Alright, so give me a bit. I will be right back for the address. Alright, I've created the address and the address model, not the address itself. And we've got this little construction over here, and you can see what I've done. I've simply created a copy with, generated it and copied it over. I've also got a from map and a to map. Oopsie daisies. Alright, I've got a from map and a to map, and I've also got an empty constructor, and I've got a from JSON, which I'm definitely not going to use because I'm always going to decode before I bring it in here, but whatever, in case you need it, I've put it in there. And so we've got a from JSON, which simply calls the address model from map, and we also got the to JSON, which calls the to map and encodes it. Alright, so this is essentially what we're dealing with. I'm going to create a wishlist product, so a new Dart file with a feature wishlist /domain /entities /wishlist product. Alright, now I'm going to do this and also do one for the models. Alright, new Dart file. No, not a Dart file, it's going to be a package. Alright, so it goes all the way from there to here, data.models. Alright, and then over here we've got a new Dart file, which is wishlist product model.dart. Alright, and that is it. So I'm going to also write this bit from what I've got on the server, or the schema on the server side. Then I'm going to do this and generate it and then show it to you, because it's just models. You probably already know how to write models, right? So let's see how that works. Right, so I've actually done the same thing for the wishlist. I've got wishlist product and a wishlist product model, and we can totally use this instead of the little replacement that I've done here, and do this as well. Alright, so over here in the address model, we're not going to need that at all. So I'm going back over to my my user model, and over here we're doing a lot of the work. Alright, so over here we've got the map talks to the wishlist key, but we're not just going to get, copy that over. And over here, I'm actually going to change this, so map a string, and in case you want to check for the underscore ID, in case the normal IDs were not put in place, which we overrode with the hooks that we put over virtuals that we activated in the server-side schema. But in case you haven't done that, you probably want to add this thingy because the ID might actually be null. So if it's null, we actually want to go over to map at underscore ID. No. Underscore ID as string. Alright, and that is it for that. But then over here, we're doing best practices. Alright, so this will always be a list of the dynamic values, alright, because you're getting it from the server, and Dart will always cast it as dynamic. Now, if you expect this to be a list of data maps, which is a list of map string dynamics, and then you cast it over to a wishlist product model, it's not going to work because Dart does not immediately recognize the map string dynamic. It always messes up a lot in that scenario, in this use case, where it throws an error when you directly cast it as a map string dynamic. So in that case, I usually just cast it as what it is, just a normal list of dynamic values, and then I extract or derive a list of data map from the list of dynamic values that I've got, and then finally .map, I map through that list and I get a wishlist product model from map, and then I pass it. Now over here you can totally go ahead and pass it let's call this data, and we pass it that data, and it will work. It will essentially work. Alright, so this is only showing red because I have to cast it to a list, so this will work, but this is totally not necessary. You could totally use a tear off, so this is called a tear off. You can go ahead and read about tear offs on Google. What are tear offs in Dart? So this is called a tear off. Alright, but we're not talking about that at the moment. So over here I've done the best I can. It also generates this with a .this, which I don't like and I always remove, so I'm deleting all of it. No, stop. Alright, delete, and delete. Nice. Alright, so that is it for my from maps wishlist. Now moving on, we also have to do the address. Now remember that for the address, there's literally no map at address. Alright, so it's listed all over the map itself. Alright, so we're going to explicitly set this. Alright, so address model dot from map, and we pass it a map literal. Now in this map literal, I'm going to conditionally provide values for each field in the address model. Alright, so we start with the very first bit, and that's if the map case. So we're using the new Flutter's if case, not Flutter Dart if case syntax. So if the street, alright, is of type string street, we're going to pass in the street of this to be the street that we've just destructured. And finally, if map case, and we do the apartment next, is a string of type apartment, and we're explicitly doing this if the street is not null. Alright, so it must be a non-nullable string. Alright, so we also have to close that up, and we pass in the apartment to be an apartment, and we also do the same for map case city. Alright, that city is also a string of type city, and we do a city to also be a city. Postal code. Then we also pass the postal code to be the postal code. And finally the country. Map case. Country. Type string country. Country would be of type country. Alright. Now finally, the address has got a is empty or is not empty value, so we're going to use that to our advantage. Right, so over here in the user model, if, where is it? No, sorry, over here. If, there you are. Now, sorry about that, the phone's actually quite nullable. Right, so I totally forgot about that. The phone's quite nullable, and over here for the address, we don't have a map at address, so we're going to use the map address dot is empty. Now if it's empty, we pass in null, else we pass in the address. I hope you got what I've done here. Moving on, we've got the copy with, we've got, we don't have this bit yet. Alright, so we've got the copy with, we've got the from map and the to map, and finally we have to edit the to map as well because it was automatically generated. So for the to map, we don't want the wish list to just be passed that way. We want to serialize it. Alright, so map each wish list, and we actually want to get a product. Now for each product, we're going to cast it. Sorry, I wrote post. Product casted as a wish list product model. Alright, so we've casted that and to map. Because wishlist product models all have to maps. Method to map is not defined for the type iterable. Oh. Where have I put it? Oh, I've actually put it outside of this, so this should rather be in here. And you should have your own bracket, parentheses, and then we finally cover this bit in the to list. Alright, so that's it for the wish list. We also do the conditional additions for this person. So if the address is not equal to null, then the address will be passed as address model. Alright, so we're always casting in order to get access to the two maps from the models. And then finally the phone. Now if a phone is not equal to null, the phone will simply become a phone. And you can skip all of this hassle by simply opting for the freeze package. Right, but personally, I love stress, really. It's just me. Alright, so finally we can also do the to JSON and the from JSON. Alright, so for the to JSON, it's going to be a string to JSON, which will simply turn as a JSON encoded version of the to map. And that is it. Now for the from JSON, we're going to put that right above the from map. Now that would simply return as a factory user model from JSON. It takes a string which is a source and it returns a user model, the from map, and we pass it JSON decode, and we decode the source which is already named correctly as a data map. Nice. Alright, now that we've done all of that, this is it for the entity. Sorry, not the entity, the model. Right, so that model, I'm going to move over that later, but I would have to run a command since I don't explicitly have access to this, or I can't cut it. It would definitely cut all of the data, but so I'm going to create another package first, and that would be a repository. So remember, we've done the contract for the entities, so we're not even talking about the wish list, we're talking about the auth. So forgive me, my head's not in the game. Alright, so over here in the data layer, we've already got the models, and that is the implementation for the entities, which we don't have here, but we have over there. Now that is for entities done, implemented, contract solved, fulfilled. Alright, so now we're moving on to the repositories. Now the repositories will also have their own counterpart over here. Again, we normally call this repos. Both of them, these two, call them repos, so these are usually shortened to repos. But I'm personally going to write them as repositories for tutorial purposes, but don't expect me to do the same for other features because it's usually quite long, so I personally don't like doing that. Alright, so in further features, I'm basically going to be writing repos and whatnot, remote data SRCs and all that. Right, but over here, for the very first feature, I'm just doing you a favor and writing them out in full. Right, so in the repository, we've got something called so over in the first bit, we had an auth repository. Now over here, we have a more explicit version called auth repository. Alright, implementation. Now in further features, I'm essentially going to be writing auth repo impl. Alright, so authentication repository implementation. Whenever you see that, it's essentially what I'm talking about. But over here, I'm going to write it out in full, again, tutorial purposes. But implementation. Alright, so yeah, that's spelled out correctly. Oh my, I didn't save that. Alright, auth repository implementation. Alright, so this time make sure to hit enter on the keyboard to get that fixed. Alright, so we've got that fixed essentially, and we're going to start out with the implementation. Now, unlike the entities, alright, what we've seen for the entities implementation was quite unique. It was where we only wrote or added functions. Were never there in the contract. Alright, so the contract only outlined the characteristics of the object, but never the functions that the object is supposed to have. You can go ahead and add those, but it's not usually convention. It's going to be too much work, basically, because everyone knows what a model should have copy width, should have two maps, but no one knows implicitly from the back of their hand what the authentication repository should do. They don't know whether we're putting in forgot passwords or whether we're letting the bus handle that, right? Because if, for example, you're using a backend as a service bus for short, like Firebase, it would probably handle most of those for you. You don't usually need explicit functions for those, alright? But that's for later. Let's focus on what we've got at the moment. Now, at the moment, we've already done that, but however, like I said, it's quite different than what we've done before. Right, so in this case, we're still, we're still going to inherit from the contract the same thing we've done for the models. Alright, so over here we've got auth repository implementation. And this time we're not saying extend, we're saying implement. Alright, so everything that implements a contract, or a proper contract, for example, the repository, alright, we'll always use a keyword implement and not, alright, and not auth repository. And not extend, alright? So how do you know when to use extend and implement? If the class that you're extending or you're trying to inherit from is an abstract class. And that's basically the rule of thumb. And not generally though, but I'm talking about data layer. Alright, when to use extend over implement. in the data layer. Right, so now I'm going to move the models over to the core. No, not there, but here. Right, refactor. Alright, that's done. Now the only way to know that would be to check if what you're inheriting from is basically an abstract class. Now over here, the auth repository, the repository's implementation can't speak. Usually depends auth repository implementation usually depends on a remote data source or not cached data source, a local data source as we call it. So we rather call the data sources that talk to the cache or to the user storage as local data sources. Right, so over here we've got a remote data source or a local data source, and those live in here. Alright, so I'm going to put a package in here called data sources. Data sources. Now in the data sources we're going to have either the remote data source or the local data source. I already taught you that with diagrams when I was teaching about the layers. Now over in the remote data sources where we will do all of the explicit things, or sorry, the more vulgar stuff like get requests and directly talking to a server. Alright, we also do things like try catches. We also do try catches over here, but over there we do try catches for basically everything, essentially, like all exceptions, and then we convert them to more calm versions of exceptions, which is our versions of exceptions, which is the server exceptions that we've created. Or in this case, we could also have a cache exception if we're talking to local storage. That is, the remote data sources will throw server exceptions which we've created, but the local data sources will throw cache exceptions which are also forms of exceptions and we've also created. Right, so this is what we're dealing with. So meaning that this person will totally depend on a sort or a form of data source. It could be remote or local. In this case we've only got a remote data source, and that should be an auth remote data source. I'm going to teach you how that works later. Alright, but for now, remote data source. For now, I'm going to show you how this works, and then come back to repository implementation and show you how it will work. Alright, so let's go ahead and mimic talking to a server. We're not going to do the actual implementation, but it also has its own contracts. Alright, so but let's look at it lest I speak too much and confuse you lot. Alright, so we've got auth. So these are also naming conventions. Auth remote data source. Alright, and over here the auth remote data source will simply have its own contract similar to what the repository has. So let's see what that would look like. So it's an abstract class. We could go ahead and make it a sealed class in order to avoid extensions from outside this module. So it's the auth remote data source. Now normally you'd see me writing src, but over here I'm going to write the full source. Alright, so constant auth remote data source, and I close that, and then finally I write out all of the contracts. Now over here we simply copy over what we've got here. Right, so we copy this over. We have quite a few differences. Alright, so over here we no longer need a result future. We directly are talking to the server, so we expect only a future. We don't expect failure or success. We only expect success, and if there's any failures we expect it to throw, alright, a literal throw. Right, so it throws a throwable, in this case an exception, for example a server exception. But over here we're expecting, over in the repositories, we're expecting either or. We're expecting either a failure, which is a Dart object and not throwable at all. So it's a type. So we're expecting types over there and no throwables at all. So as I was saying, we didn't want our apps to crash, and that was why we're handling throwables and making sure that by the time we get over here, we no longer depend on throwables because those crash the application, right? But over here we're still dealing with throwables because we're directly talking to a server, right? So that is the reason why we directly use futures and future, and also something else. We also always make sure that whatever the remote data source functions return are model versions of their objects and not the raw object. We're not returning entities in the remote data source, we're only doing models. Alright, so some of you have asked me this before. Well, why don't we declare the contract over in the domain layer? And you're quite right, we can do that, but we've already got that over here. Right, so whoever looks at this already knows what the functionalities that this entire class or this entire feature bears. All right, so it would be some sort of form of tautology which we don't want to commit, but we need it because it's kind of different than what we've got here. It returns a future and its types are also model. So you can look at this as a more general and more Dart friendly contract, and over here we've got a more rough, wild version of the contract, right? That directly is not scared of crashing the application. It directly throws errors when it sees them. All right, so this person is more of the warrior, a soldier. All right, the other person is a normal civilian who doesn't like to deal with handling the ugliness of war, right? This person is quite experienced and they're going to get it to handle it gracefully. So that said, we could go ahead and leave this as this. All right, so this will have its own implementation. Right, so I hope I answered that question. Let me reiterate. The only reason why we don't put this in the domain layer is because the domain layer has already got this in a milder version that's more user friendly. All right, now that we've established the contract, we could go ahead and use that contract over here without the true implementation, which we're going to do later. Right, so the true implementation will also happen or occur in the same file, the same module over here at the bottom. So we do the implementation over there. You could also go ahead and write the implementation as a standalone module. Right, helps modularization, but personally I don't see the need for it since we've got a single file and they live in the same layer and in the same directory. Right, so for these ones we could excuse them because they're totally different layers. Right, so we don't want to put the implementation in the same file as the contract. Right, so over here in the implementation of the repository, I'm going to show you exactly how this works. Right, so you can see it's underlined red and we can create 6 missing overrides and it's automatically done that for us and we don't have to worry about that. So we could just simply go ahead and do some edits, add some asyncs over here and copy that async, copy, paste, 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 and paste, and paste. Alright, and for those ones that are overflowing in there and parameters, we're simply going to add commas and format. Alright, so we do a control alternate L, alright, and that formats the file, or you could right click and format with Dart format. Alright, so we've got the remote data source, and all we're going to be doing, it's quite simple really, it's very sweet. The repository implementation is very simple and sweet. Alright, so we try, over here we try, so we're expecting that the Auth remote data source will catch whatever harsh exceptions that occur either from the server or from our little Dart code, and it will throw it as a server exception. So we're only expecting to get a server exception from whatever happens over here. Why is that? Because over here we're only going to call the remote data source dot forgot password, for instance. Alright, so we're only interacting with the remote data source and we're very certain that any other sort of exception is handled in here and converted into a sweet server exception that we've created. Alright, so we pass it the email. Alright, so that is it for forgot password. It passes an email, the forgot password handles the email, sends it over to the remote data source's forgot password, which we've created as a contract which we're going to implement later, and it simply handles it. And then finally we'll return. Remember, it wants either a right success or a left failure. Alright, so in this case we are going to return a right, but remember the right hand side is from the Dart package. Right, so we can import Dart and it returns a right side. So it's quite literally right or left. Right, so the left will always be a failure and the right will always be a success. Right, so in this case it can't be empty, but we've got a void, so we don't have anything to return and we can't put void there, so we have to put null. Right, so it's a right with a null, which means void. Right, so over here you can see we're still not done. It expects an either or. So in this case, in the case of a server exception, we're going to return a left. Right, because it's the left hand side, and the left hand side is always a failure. And in this case we're going to return a server failure from exception. Now normally without the from exception constructor you were going to have to write a server failure and put in the message to be the exception, which would be on exception E, on exception catch E. You were going to do the e.message, and that was going to work because the E was a server exception, and the server exception has both messages and status code. Right, but over here we've already got a constructor to handle that, and that would be the from exception, and we simply pass it the E. And thank you for that. Alright, so I've worked on many projects where I've explicitly had to write out the e:/e.message, the message colon e.message, status code e.status code over and over and over and over again. Right, so I simply do it this way now by writing a named constructor. Alright, so we can also do the same for login and the same for register and so forth and so on. Alright, so it's going to be the same thing, but I'm going to do the login with you in order to show you how it works when we've got a return type, because over here it was basically void. Alright, so over here we've got the same try catch. Alright, the try catch will simply repeat over and over and over and over and over and over again for all of them. Now we've got final result, so we save the result this time in a result variable. You can call that variable anything you wish, but personally I always call it a result, and we do the login and we pass it the email and password from the same constructor. Alright, and we simply close that and put a comma. Right, and after that we go ahead and we return a right, and the right will contain the result. Right, so whatever is your right return type, remember that the result future is simply an either failure, which is on the left, or on the right hand side, the type that you've put there. Right, so over here we've put the user, meaning that this would become either future, either failure, or a user, so it's expecting a user over there. Now meaning that on the right hand side we're going to call the right constructor and pass it in a user, and this is simply a user, and it's a user model, but a user model extends user, so essentially we're passing a user. And the left hand side is also returning a failure if a failure occurs. Right, so one or the other is going to be true. Now when we're handling this, you will also see how to handle either or when any of them happens. Right, so alright, so moving on, I'm going to do the register, reset password, verify OTP, and verify token. It's very simple. We simply call the root data source and we return right or left depending on whether there's a failure, or whether there's an exception, or whether it completes successfully. That's how it works. And I'm done. Alright, so the only little issues would be the overflows, alright, so which I'm going to fix by adding commas and formatting. I think I've got an error. I've added an extra bracket and I'm going to format that, and we've got a beautifully formatted, except for you. So I'm going to format you as well, and yes, that is it for the remote repository implementation. Now finally for the remote data source. Now the remote data source has already got a contract. We've seen how the contract works. Now we have to see how the implementation also works. Right, so for the implementation, you simply have to go over to your Postman and see how the endpoints work. Alright, remember, we've already looked at that and seen the things that we require to pass over to the endpoints, but however, I'm saying to go back and look at it because most things are not body. Right, some things will go in the body and other things will go into the query parameters, and other things will also go into the path parameters. Now each one has its own way of doing it with the HTTP library or the DO library, whichever one you decide to go with, or any other library that you request to go with, it doesn't matter. Right, so you have to look at your backend or your server configurations or your setup and the architecture and how it all works and know exactly how this works. But we've already built out ours, so if you built the backend with me, so you already know how that works. So we're simply going to do that and use it to our advantage. Now, moving on, I'm simply going to start with, alright, I'm going to format this first and then start with an implementation of a contract, right? So it would be auth remote data source implementation. Double T, which is quite silly. Implement the auth remote data source. Now this bit actually helps me do the override, and we already have override. I'm simply going to add commas to all of them, and we've already got the async modifiers, and we can put commas and comma and add all of our asyncs to all of them. Async, 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 async. Oh my days. Alright, that looks pretty decent. Alright, so let's start with the proper implementation. Now, the very first thing would be the forgot password. I actually wanted to do the register first, but the automatic override creation put the forgot password first. Now, over here, this implementation will also have a dependency. Now, we do the dependencies over here for the I principle in the solid, which is the dependency inversion. Now, this simply helps us inject a fake version of the, for example, auth remote data source when writing tests. This also will be the case over here when we're writing tests for the auth remote data source implementation. So this was rather for the auth repository, not the remote data source. And over here, we've got the remote data source implementation. When we're testing this implementation, remember, we don't test contracts. We test their implementations, and over here we can pass it a fake version of the HTTP client library, so that way we can hijack whatever requests the library will try to make and give it a fake answer, give our data source a fake response. Right, so for that reason we're going to have this as a constructor, and we've got a constant constructor, and it will take this dot underscore client. I always love to make my architectural dependencies private, so final HTTP dot client underscore client. Right, so for that reason we import client at the top. That would be import HTTP dot. Nice. Alright, so we have to add that. That would be footer, pull bad, HTTP, and footer, pull get. Alright. That'll soon, and you see that reflect there. Now, moving on, we're simply going to implement the forgot password first and then carry on with the rest of them. So for the forgot password, we're simply calling our server and we're doing a try catch as always. Now, this try catch is quite special. Right, so in this case, we've got a catch, alright, a catch for the exception and the stack trace. Alright, so for developer purposes, we're simply going to debug print the e.toString. Alright, what has been imported? I don't want that, I only want the foundation. Alright, so beautiful. And then finally, debug print stack. Alright, so over here, the stack trace will simply be the yes. Perfect. Now over here, if we cache that, we finally throw a server exception. Now the message will simply be the e.toString. And finally the status code will be 500. Now I'm putting 500 because I'm basically certain that if this throws over here, we've only got an exception that occurred because of our personal issue in our Dart code. Alright, so this will only be triggered when there's an issue from our Dart code, and that's the only time when there will really be a throwable that we can catch with a catch block. And in that case, it's from us because we're the server. Well, basically not the server, we're the client, but in a way where the server, so whatever, so I always put 500 over there. Now you also have to put in mind you don't want to show the user the server exception the way it is. Like, you don't, if this throws, it means something's happened over here and it will be very dirty. It could be something like for example, it could be something like this. The body might complete normally, causing null to be returned, but return type, you don't want your user to see all of that. It's a huge mess. Server exceptions are usually a huge mess. So you usually always want to replace it with server exception or unknown error occurred, something like that, or just something that we always return when there's a 500. Alright, so in my case, I'm just going to say unknown, or let's just say something went wrong, or let's say no, it's not your fault, it's ours. Alright, think I love that. Or is it Tuesday yet? It's ours. Alright, so it's not your fault, it's totally mine. Alright, so we added constant, and we will know what's happened because we printed it over here. But if you don't like looking in the console, you can always put the error message over there for debug purposes, so that it shows up on the screen, and you always handle them because you know they're never going to go production if you're very confident in your skills, that is. Otherwise, don't attempt it. Alright, so moving on, we've also wait, let's see. Yes, so finally done and imported finally properly, and we can go ahead and construct the URL. Now, final URI will be equal to URI.parse. Now, in my case, at the very moment, we've only got the localhost. We haven't hosted it yet, so it's going to be HTTPS localhost. But over time, after the development is done and you've done a deployment, you're going to have a different authority, right? And also a different protocol. It's not going to be HTTP, it's going to be HTTPS. So for that reason, I prefer to save this in a constant, so that way I don't have to go through all of my remote data sources and change the protocol and the authority, even the endpoints, even if possible. So I'm going to basically abstract everything about any URL that I use, all of them. So for that reason, I'm going to go over to my core and create in the utilities constant. Right, so this constant will bear, let's call this a network constant that will bear all constants for my network, essentially. So let's go over to my utilities, new Dart file, and that would be constant network constants. I'm simply going to make this an abstract class, network constants. Finally, static constant. I'm going to have a base URL, which will be equal to HTTP 127.0.0.1 loopback service, and finally we have on port 3000. And yeah, I believe that's how our server works, the server we've created earlier in the Node.js version of the tutorial. Now, finally we have API/v1, and this was why I wanted to create the server before the front end, because I had to teach you all of this, and if we hadn't done the server bit yet, you would have been very confused over here, right? So this is why you're here for the architecture, and the architecture required me to teach you the domain to data before the presentation, and that would have required me teaching you this, and wouldn't understand what I was talking about the API v1, but we've already done all those, so easier for me and easier for you. Now, in some cases, you might actually want to use the URI.http or HTTPS, which asks for an authority. In that case, we rather want to do this. So static const authority. The authority would be the loopback service 127.0.0.1 on port 3000. And after the authority, we would have the API URL, which would always be the API/v1. Now, whenever we change it here, it changes everywhere else. Now, we also have the headers. The headers are always going to be a part of every request, and we never want to miss the content type header. So, in my experience and in my years of building Flutter applications, one thing that always causes HTTP requests to fail is, and they give you such generic messages, you don't even know what's going on. So you're just usually using the application JSON content type, blah blah blah. So alright, so we also have let's say a page size that I also want to be dynamic over. So these are constants from the network side. Right, the page size was usually 10. I don't think I'm ever going to change it, but in case, I'm just going to put it here and always use the network constants page size. Right, so that way, if we decided to always have 20 for a page size, it wouldn't be that much of a hassle to change it. Right, so network constants done basically. Now over here, I'm simply going to implement, change this to parse at first, and then implement what I've just created. Alright, my little Frankenstein. And over here it will be the network constants dot base URL. Right, so it was the entire thing. The API v1 blah blah blah. And over here we also need to write /register. But I'm not going to do that because again, things might change. So I'm only going to put them as constant. So every route has got its own URL. I'm going to put their endpoint, their URL endpoints, as constant over at very top of this, right at the center of between the contracts and their implementations. This is how I personally do this. You can totally do this anyhow else you want. Maybe create a network constant for particularly this feature, or do whatever you want really. It works anyways, alright? So this is my thing. You don't have to follow me or bite of my ears about why I'm doing what I'm doing. It's just personal preference. Now, personally, I have some background from Python, alright? And over there, we declare constants this way. Now, you could totally go ahead and do the register endpoint, but just my eyes, mate. It's a constant, alright? So, I just personally want it to be this way, but it screams at me. So, one thing that I could do would be to show context actions, and I actually want to ignore it, but it's not showing it over here. It usually did. So what I'm actually going to do would be to ignore it at the top, and for that reason I'm going to go over there and use this rather. Ignore for the entire file. Right, alright, so it stopped screaming at me. Right, you could totally do the normal way that we do it for Dart. I know the Dart people are going to come for me, the Dart police. I'm so sorry, Dart Police, but I'm just so used to doing that for constants. I'm so sorry. Right, so Dart Police will get me for that later. However, for the meantime, we're going to move on. And finally, I'm simply going to use the forgot password endpoint. I'm simply going to delete that because it's already got a / in the forgot password endpoint. So I'm simply putting it the way it is. Alright, so that would be forgot password endpoint, and comma and close. Alright, nice. Now finally I've got the response. I'm going to put a space between those two, and response would be called await. Alright, I don't have the async modifier. Async. Alright. Await for the client. Dot post. What are we posting? We're only posting the URI, and we have a body which is JSON encoded. So email would be email. Nice. After that, yes, I forgot the headers. Right, so we've got headers for all calls that now come from network constants.headers. Should be headers rather than header. Alright, F6 headers. Alright, while that's taking its precious time, alright, yeah, that's done now. And finally, we could check if response, because we're doing a push request, all right? So it's probably going to change it and return either a 2, but the push request usually return 201. So if you really want to cover all cases, you would know that push requests usually return 201. So if for some reason you want to cover all cases by maybe you don't trust your server guy, you don't know he's really unpredictable, you could totally also check and see that and response or status code is not 201. But in this case, we pretty much trust our backend guy because it's us. We've done the work, and so we're pretty certain the forgot password only returns 200 and not 201. Alright, so final payload would go over to JSON decode, and we decode the response.body as a data map because we also return errors in that manner. Finally, we throw a server exception. However, I don't always want to have to sort the payload out myself, because you see what we had in the when writing the server, when we wrote the server. If you wrote the server with me, we had cases where we had error messages, right, and not just errors in the map that we got from the error response. We had error as a key. We sometimes had errors, right, and we had to sort through lists of errors, right? So in such cases we would have to do different things. So I want to create a functionality for that specially, right? So I'm simply going to create in my core folders, maybe put that in the services or something, or maybe put in the utilities. I actually want to have an error response, or some sort of handler for the errors that will simply handle errors for me, is what I'm trying to say. Alright, so where could we put this? It could totally go into services, but I'm gonna put it in here. Alright, so to sit with the rest of the utilities. It could come in to, yeah, I think this isn't too bad. Alright, error response, and it would rather it's some sort of model. So, but I don't want to put it as part of these models because these models are usually tied to the network, to like entities and that, right? But yeah, it's whatever, mate. You could think about where to put that. These things aren't very much tied to the architecture, so those are usually up to your personal preferences. Alright, so error response extends equatable. There's no reason to add value or quality, but I'm personally just, a sucker for it. But yeah, it's whatever, mate. Now, constant error response would include this dot type and this dot message, and let's say this dot error message. Error messages. Now finally we have factory, right? Error response not from map. Now this will take a data map, a map, right? And I also believe that I forgot to swap this out for the other model over in a core folder. It was either in a core folder or somewhere else. I don't know. I'm just going to do a replace, and we're replacing a map string dynamic, which was over here. All right. Going to replace that with data map. Replace. All right. Nice. And over here, we're simply going to return. Sorry, we're not just going to return right away. We're going to do some formatting in case we've got a map or a list of them. Right. So this will come in the form of errors. When it's multiple errors as list, which is actually quite nullable. So dot cast, and we cast a data map from it. That will be a list of data map of errors dot map, and we dot to list. Now after we do this, we go back up and we simply get each error, and for each error we actually want error at its message as a string. Nice. What am I doing? Is that... Yeah, so alright, so that's it. The syntax formatting just confused me. That would be an if error messages is not equal to null. However, it's not null, but it's actually empty. If it's not null but it's empty, we go ahead and return the error, make the error messages become equal to null. Alright, so that way when we're returning the error response, we don't have to put it as part of it. So finally, we do a type to be a map at the type of the error message as a string. Now the message will simply be map at message as a string. And finally, the error messages would simply be error messages in case they're null. We ignore them. What's the matter? Map at type as string. What have I done? Alright, assume. Alright, yep. Now finally, the data itself, and it would be final string type, final string message, and final list of string, which is also very much so nullable. Messages. Now we can also construct the error message over here. I'm simply going to skip that bit because it's just, it's going to be super long. This is what I normally do, so you could just copy paste it from the source code that you will find in the course resources. I've created it, and while creating it I figured out, or I found out, or I was putting error message instead of error messages. Now I intentionally put it back out after correcting it because just to show it to you that we did something silly. Alright, you can see my, oh my, running out of disk space. I've also overridden the props, and we've also got the error message. Right, so you can see what I've done. I've simply done a lot of concatenation and all that. And we can also see what's going on here. So over here, we've initialized a payload, and that payload is going to be initialized, or first of all sets to be the type, right? If the type is not null, that is. Now after that we go ahead and add the message if the message is not empty. Else, if the message was empty, we go ahead and check if the error message is not empty or null, because it turns into a null basically when it's empty. We've done that over there. Now if it's not null or empty, we go ahead and use the index from the Dart collection, as you can see over there. And we simply use that to get an index and check of the first message, and we append it with only one line. Right? Otherwise, we append 2 new lines for every subsequent message. Right? So that basically explains it. We're just chucking and sticking all the messages to go on. Right? So we could go ahead over to the remote data source, to our implementation of the forgot password, and continue with our little spell we're concocting. So over here we can go ahead, and rather than throw the server exception directly, we can form an error response. Right, it would be equal to the error response dot from map, and we simply pass it the payload as a data map, and that is it. Now finally we throw an exception, server exception, and the message will simply be the error response dot error message, and the status code will be response dot status code, and that comes directly from the response and not from the error response. Right, so that is it for how these things work. This is basically what we're doing. Yeah, this is it. Super easy, super sweet. Now for login, we've got quite a different scenario than we've got here. You probably already know what's going to happen. It's the same thing, except returning the user from a response this time. Right? And we're forming a user model from the actual user. But remember that this is why I made it, I told you that conventionally in the remote data sources contract we make sure that every return type is a model version. That way it forces us to actually return the model version. That way we're able to perform copy widths and to maps and from maps. Right, so because it forces us over here, so we're pretty certain that every other place along the lines or in our tree where we hand over and do the implementations, it always works the same. Now also remember that over here in the forgot password we've actually done something quite weird. Right, so over here we're only catching every other exception, meaning that the server exception will come in here. Now if the server exception gets called here, it means that it will be treated as a 500, which isn't very true. Alright, so remember what I promised you. I actually promised you that every exception we're catching here we will make sure that it only comes from Dart. However, when we throw this exception, it will be called here before it gets rethrown out there. Alright, so in order to avoid that, we can specially catch that, and on server exception, right, we can put a special catcher. When we catch that, we do what we rethrow the server exception. So we've got a catcher for it, and it simply rethrows that server exception on its own without handling it as a special server exception. Alright, I hope that makes a lot more sense. Now, moving on, I'm simply going to do quite almost the same thing. So I'm going to copy the on server exception bit and just put a try. Alright. You're already pretty familiar with this. No, what am I doing? Nice. Now constants dot base URL. Also append the login endpoint. Remember what I've told you, URI, and after that the body. Now the body should always be encoded. So encode, not node, encode. Code, and we encode an object, and that'll be the password. It comes in the form of a password. And we also got the email, which also comes from the email. And finally the headers. Network constants dot headers, and I keep doing that silly thing. Oh my. What in the world is wrong with me? Am I getting old? Maybe I'm getting too old. Maybe I'm getting too old. I need help. Let's data map. Alright, I'm basically speed coding, but I hope you understand what I'm doing, yeah? I've created the URI. I'm expecting you lot already know how to do ACP requests, but it's essentially what I'm doing, using the ACP client, doing a post request with the body headers, and I'm catching the payload from the request response to body and casting it to a data map. Right, so moving on, I can response.status code. Now it's a login, but I know that personally my server's returning 200s for logging in, but I don't know what your server's returning. So whatever is returning, make sure you catch that over there. Right, so final error response. Now the reason why I'm doing this out here, as opposed to what I've done in here, was because we didn't have anything else out there. So yeah, so over here we're going to use it after the if block. Right, so error response dot from map, and the map will be the payload. Right, and after that we can throw, I could copy that, and nice, sweet. If that was a status code 200, after that we do a return user. However, we're doing a, oh wait, what's the matter? Oh, I haven't constructed my user. See how silly I am. Oh my, I'm really getting old too, lot. User model, payload, All right, so yeah, so now I can boast about my code, but yeah, I know it's quite pretty. Yeah, my code is pretty, isn't it? So we can see this beautiful piece of code, right? Quite sumptuous, but this isn't all we want to do really, because remember that we've got a cache where we cache the user's ID and their current session token, and over here we get a session token, an access token. Yeah, so we want to take that session to access token and cache it, and also cache their user ID. So we do all of that in here. We could totally hold this off. Personally, I'd advise you to hold it off till we get to the presentation layer, and we do that uh, in the interface adapter. This is personally where all business logic goes into. But there's also, I'm trying to show you that we're being flexible, right? You're not forced to follow a particular pattern, whatever pattern works best for you. I'm personally not against it. I'm not teaching you to follow this pattern. I'm teaching you ditto, right? It's anything that makes life easier for you, but also make sure that you're following the proper architecture that makes just the things that make clean architecture very useful, right? Those things that make it helps it make your application robust, loosely coupled, testable, scalable as well. All right, so these things might feel more difficult to do or feel like you're wasting a lot of time, but at the end of the day, that more robust, scalable, testable, and all that. Right, loose coupling is my favorite thing about the clean architecture. How everything's loosely coupled. One department or one layer can totally be deleted without really shaking. Right, they're coupled, right, but it won't really shake the other layer. Right, because we've got them being dependent on each other by their contract. So if the contract still exists, then there really won't be an error in subsequent layers. If, for example, we deleted the remote data source, or if we deleted the remote data source implementation, there will only be an error during injection, and there won't be an error in, for example, the use cases because they depend on the contract. Everything else depends on the contract. All right, so this is how it works. Now, I'm expecting that there's a cache helper in my service locator, and that would be cache helper. Bada bing, bada boom. All right. And over here we have injected a cache helper, so we could totally use it. We could see the cache session token, and we're caching the session token, and it goes into payload at access token. Man can't spell either. All right, so after that we save the user and we await SL cache helper. Yeah. And we do the same thing for cache user ID, and we do the user.id, and then we return the user. Fine, perfect, done. We're going to do the same thing for the register, for the reset password, verify OTP, verify token. It's the same thing, yeah, it's literally what we're doing. I could literally even just copy paste and do the same thing. It all works out. So you don't complain for skipping the video and doing something behind the scenes. So I'm going to do it in front of you, but I'm going to speed up the video. I believe we're done now. Right, and over here we've got the verify token, which is the very last bit. However, the rest of them are very unique, such that they never required token renewal. Verify OTP meant you were outside of the token system. All right. Reset password meant you were also out of the token system. You didn't need validation. You were being validated, or you were changing something about your authorization or your authentication. However, the verify token happens every time the application starts in order to verify that your token is still valid. Now remember how our token system works. We have a refresh token and an access token. Now the verify token, it checks your cache for the token, takes the token from the cache, sends it over to the server. The server checks, and the token is always going to be the access token. Now, that access token will definitely match a refresh token that lives on the server. Now, that refresh token will be fetched, and if the access token has already expired, the refresh token will be checked for validity. Now, if the refresh token is still valid, then it would surely be used to get a new access token, and the new access token gets sent over to us. Now this happens for every single request that lives outside of these requests. Alright, so every other request that happens in subsequent layers, subsequent features that we implement, will actually carry that thing. Alright, so because we've got that little middleware that we've written on the server to handle all of that. Now over here, I'm simply going to write some sort of automatic token renewal service to handle all of that for us. Alright, to handle checking if it's expired and getting all that. Alright, so for that reason, I'm actually gonna first of all do the request thingy. Alright, so like if you watch the sped up part of the video, you would have noticed I was just basically copy pasting what I had before and then correcting the endpoint and some things in them. Right, so over here we're doing the verified token endpoint, and then after that over here we're not doing a post, we're doing a get, and that is small letters for you, get requests. Now over here we still certainly need the headers, but the headers is not going to be this headers, so I'm going to rather use the cache.instance .session token. We certainly don't need the body because we're doing a get request, right? And I'm going to do that .session token. Now this session token, I don't just want it to be there. I also wanted to have headers, content type headers, which was application to JSON, which we already have the network constants. Right, so for that reason, I'm actually going to write an extension that will particularly take the session token and turn it into a header. Now I'm doing this for posterity because I don't really know if I will need to do this later on. If I do, then I will simply wish not to have to create the content type application JSON over and over. I could simply do that here, but again, I don't know what's going to happen later, but yeah, so I'm simply going to do one default bit here, and the headers are always going to be string, which don't match with the data map sort that we've got, and it's going to be two headers, two auth headers. Alright, so it could be anything, would convert it into an authentication header. I'm going to return authorization to carry bearer, and then carry this, and then we've got the content type, which simply is always application JSON : charset UTF-8. Sweet. We're back here, so we can simply just do a dot. This is very much very normal. So we're verifying the OTP, and we're pretty certain. No, I'm not certain the OTP exists. What if the OTP does not exist? What if it doesn't exist? I think I already handled that in the services over there. So if it never existed, it wouldn't even push us to the verify OTP in the first place. Alright, so over here in the router, no, that was rather the router main. You can see it checks the cache for the session token, and if it doesn't exist, it redirects them to a login screen. Alright, and if it doesn't exist, it then goes on to push them to the splash screen, which is where the tokens will be verified. So at this point, we're pretty certain the session token exists. Alright, so if it exists, two headers, two auth headers, and it sends it over as a header, and then the server will do its little authentication, but we're putting out the payload out to the top because we're going to use it outside. So, oopsie daisies. I've actually just found out that I was doing all that to the verify OTP instead of a verified token. I'm so sorry, people. I really need to sleep. I really do need that sleep now. Alright, so this is changing over to a get. I hope that's all I've messed up here. If it wasn't, then we'd find out later anyways, because we're going to run this, see whether it works. Now over here we're using the cache dot session token instance rather. Now I have to do the import and instance dot session token dot put a bang operator dot two auth headers. Nice. Now after that, I hope this is all I need. Verified token. This is still verify OTP perfect. I haven't messed that one up. And after that, we're certainly not going to put this in here. I'm putting it out of there, because I'm going to return a boolean with it. Alright, so over here we check if it's not 200, then we do the same payload as a data map and we use it down there. Because for the verified token it returns true or false, but when it's an error it returns a data map. So I'm totally removing this right hand cast from over here. I don't want that cast over there, because by the time we're done with that, we're simply going to return the payload as a boolean, because if it's not an error, then it's certainly either true or false, which is exactly what I'm doing in the server side, on the server side. And over here we rather want it as a data map, so payload as a data map. Nice. Now the payload will simply be a data map, and we do this little, I don't know what we're doing here, but we're doing some little ritual over there to convert it into a response, some proper response. And after we get the payload, we actually want to take this payload and renew the token. Check if the token needs renewal, and if it does, do a little bit of renewal. So for that reason, I'm actually going to go over to my network utilities and create a little network util to handle that. So that would live here, new dot file. It goes into network utils, and it actually goes in here to abstract class network utils, and it goes into constant network utils, static future, goes into a void renew token. Response, so it takes a response object from the HTTP library. HTTP, I'm going to do that as HTTP, as the convention's always been. You can totally leave that as it already is, but I'm personally just going to do this. Else, alright, so if response.headers contains authorization, remember, if you don't understand what I'm doing, then you haven't watched the back-end aspect of it. Now, in all honesty, I don't have the energy to explain it over again, but because I'm such a nice guy, I'm actually going to explain it to you. So what we're doing here is actually that response.headers will return us the response. Actually, this isn't what the request. All right. So normally, a request would send authorization headers over to the server, and the server would authorize you and know whether you have a correct access, or whether you're requesting for the correct contents that you've got access to. You've got the right to access. Now, in this case, the reverse is actually true, because the response is rather sending us over authorization headers, meaning it's the older version has expired and it's sending us over a new version. If you don't remember this, watch the back end part again if you've forgotten. Authorization, *, and finally we go ahead and if the token starts with bearer, we go ahead and token will become equal to token.replace first, and the pattern would be bearer. Replace it to an empty string dot trim. We want to remove all spaces. And finally we wait for the SL cache helper dot cache session token and after we do that cache session token, we do cache the token, and else if a response.status code is equal to 401, we take the the router main. We take this root navigator, this navigator, and we pop it to go back to this router, right? So if for any reason, right, while handling the response, and then the response status code is 401, meaning unauthorized, you're not authorized to access what you're trying to access, we simply push you to the / route, and it will then check again for the cache, for the token's validity. If it's expired, it pushes you to the login, and if it's not, it pushes you to the splash screen, which will eventually push you to the home page. Right, so we want to offload whatever else happens unauthorized 401. We want to offload them back here. Now, for that reason, I'm going to add a key, a navigator key, and it's going to be a root navigator key. So this way, we can actually carry out contextual actions without having explicit knowledge of where we currently are in the widget tree. So with this, we can actually access the context of wherever we are in the widget tree, and we will know right exactly where we are, and like pop from that page or go from that page to the next page, or show a snack bar on that particular page without actually having access to that page's explicit build context. All right, so I'm going to do a final root navigator key, which will be equal to a global key of type navigator state. All right, and navigator state handles that very perfectly and gives us the status code when needed. Sorry, or status code context when needed. So we do a root navigator key dot current context dot go, and we go to /. If you don't know how to use a Go router, go read documentation or watch some what's happening. Alright, it wants me to be sure before it lets me import, and after that I can actually put this back as a question mark and it would still work. Alright, Darts and its little shenanigans, I really dislike it for that, but what can I really do? Nothing really. So let's carry on. Let's totally carry on. So that is it for the network utilities. I can come back here and in all with all confidence say this.renew token will pass the response. So we're actually going to have to call this function in every other remote data source function we carry out in every other feature. Alright, so that way if something goes wrong or if a token expires while we're doing a request, the request will actually conclude successfully, but we fetch the new token and we store it in the cache, or sorry, we store it in a cache, yes. And if anything goes wrong and it happens that let's say the refresh token that sits on the server, no, or maybe on the database rather, the refresh token that sits on the server on the database has itself expired, then it throws a 401, and in that case we rather navigate them to the login page because the token's expired, and then the request won't fire. Right, so let's say for example they're trying to view their cart, and in that case we would also have to fetch all cart products, and in that case if their token's expired during the time that they're trying to view the cart product, it will rather push them back to login and say maybe throw a snack bar of some sort and say token expired. Alright, if also they're probably trying to post data to the database, the data will be posted. Sorry, if the access token is the only thing that's been expired, the data will be posted and returned to them as a success. But if it's the refresh token or something else has gone wrong, some sort of authorization error, then it won't post that data to the database, but it will rather throw them on the client side back to the login page. Right, so that is exactly how all of this would work. And this is it for data layers. Alright, so we're simply doing anything that you'd normally do in your, let's say, your repository. If you're using an MVC, it's everything we do there, but with some class, essentially. Alright, so just a classy way of doing things. So this is it for the data layer. Next up, we're going to see how the presentation layer would integrate with this using the not an integrator, using the interface adapter. And hopefully we also write some UI code, because you lot have probably been waiting ages for that. Alright, so see you lot in the next bit. So apart from all of these, close all tabs, yes. Apart from these, we've got the presentation layer to work on now. So in the presentation layer is where we put the interface adapter. Right, remember what the interface adapter is? It connects the views to the data that's been fetched from the data sources, and it also connects the domain to the data. And how does it do that? By depending on the use cases. Alright, so we know what dependency is. This use case depends on the authentication repository. Right, so this is a dependency. So if our interface adapter depends on this use case, the use case in turn depends on an authentication repository, and when we're doing dependency injection, we will see how they all come together. Alright, we'll see how we could inject the version or our version of the repository from the data layer into this use case. Alright, so that way this will in turn implicitly, like just automatically, become dependent on the data layer, and then the presentation layer through the adapter will be connected to that use case. This in turn connected to that. So in here I could create a new package. It goes into the app, right? So, and then we can have the adapter. Now personally, the reason I do this, put in an app folder before the adapter folder, would be because normally we don't only have the adapter as our application logic, right? So the adapter works in that sense like an app logic, because if you're using bloc, for example, for the interface adapter, it will live inside the presentation layer as a business logic, as an application logic, essentially. And if you're using Riverpod, you do the same thing. If you're using getX, you still do the same thing. Now, apart from the interface adapter that particularly is written to connect these services or these sub layers, we actually can have just state management, because the thing in Flutter that we use is the adapters, or the interface adapters, are also things that we use for state management. Alright, so why? Because they're reactive. They can alert the user interface of when something changes in the other layer. So if the data layer is pumping new data to us, we don't just want to receive it in the interface adapter, we also want to alert the UI that something has changed, essentially. So in order to do that in Flutter, we'd have to use a state manager. Now, these state managers are now acting as two things, either as an adapter or just as state management, local state management. And for either case, we will have, for example, if I was using something like bloc, which requires a whole folder for each one, we would have several folders in there, right? So we'd have more than one folder, and for that I usually put the normal state management blocks, or in the case of Riverpod providers, each of them in separate folders. So the adapters will be in one folder and the other ones will be in the other folders. The same for getX as well. It doesn't matter what state management you're using as your interface adapter. Whatever you're using, simply make sure you separate them so that they don't you don't mix them up, essentially, is what I'm trying to say. So you can do that however you see fit, really. This part is not really strong on the architecture. Again, we're trying to be as flexible as possible, right? So, but then the main architectural directories will be the data, domain, and presentation, and in each one we should have a use cases, repositories. We also need to have data sources and repositories and models, and then entities in there. All right, so over here we need to have an adapter, and then we also need to have views. Now, how you're going to put the adapter and what folder you're going to put it doesn't matter. There's no layer in there. Now, the reason why I keep saying that these matter, including their naming and having their subcategories in them as well, is simply to have conventionality in our code base. So that way, anyone who picks up our code base knows what to do if they knew clean architecture. So no matter where they've learned clean architecture from, they'd always know to look in the repositories in the domain layer, and also always know to look for the implementation in the data layer repositories. So this is basically how it works. So just to make it so that your code base isn't totally different from other people, from what everyone else is used to. So this helps your team and the rest of them. In order to get started with the adapter, we're using Riverpod as the state manager of choice for the interface adapter. So for that reason, I'm going to add Flutter, add Flutter Riverpod, and we also have Riverpod annotation. Flutter, there's two T's for that. Alright, so that's double T for you. Hopefully that works now. So we need two more developer dependencies, and those are Riverpod lint and Riverpod generator. Alright, so while that adds, yeah, so that's actually done. I actually forgot to get dependencies after that. Right, so after that's done, we could go ahead and create a Riverpod adapter for this. And in order to do that, we are using the new Riverpod API, and that's why I'm introducing Riverpod annotation. So you could go ahead and read the documentation, but I'm simply going to explain them to you as we do it. Alright, so this is the package that you need for Riverpod creating the adapters or creating your state managers, and this is the thing you use to annotate them for the generator to run. So basically what we're doing is we're going to create Riverpod classes or Riverpod objects, and then those objects aren't quite enough, right? They need to generate values for it, or to generate the actual Riverpod providers for us. So in order to generate the actual providers, we give it a template, and it will generate a provider from the template that we provide. Right, so then in order to make the build runner, right, I actually haven't added build runner yet, but we have something called the build runner. But in order to make the build runner know what we're doing or see exactly, let me add that while we talk. Flutter pub add build runner and Flutter pub get. So the build runner is what Flutter or Dart uses for code generation. So the build runner will scan through every file in your code base and try to find an annotation on any file. So any files that has been annotated and the annotation actually is for generation, code generation, the build runner takes the template or the class that was marked with that annotation or the function that was marked with that annotation and actually generates code for it. Alright, so the code to be generated based on that template has been defined somewhere in the Riverpod source code. So in the Riverpod source code, it actually lets the build runner feed it with template information, which is what we're going to write, the template, and then it will in turn take values from those templates. For example, the build runner. Over here we've got an override. This is what we call an annotation. So the build runner will actually run through, and if this annotation was for Riverpod, it would take the class that was marked with it. In this case, the function actually. So it would take the function, take the function return type, the function's name, parameters, return whatever it does in there, and it takes all of that information and feeds it back to whatever source code created the annotation. In this case, it comes from the Riverpod library. Alright, so that is actually what the build runner does, and this is how it works with code generation. So now the codes that they've written behind the scenes will actually write code based on this, based on the information that it gathers from the annotated classes or functions, and then finally returns those code to the build runner. The build runner creates a new file in your code base and pastes that code in there and formats it. Right, so let's see how that works in practice. So we've got build runner now, hopefully, haven't we? Oh, silly me, I've added it directly there. Should actually be a developer dependency. Pub add dev build runner flutter pub get. Right, so that's it. Nice, so that's added. The build runner as a dependency, and we could go ahead and create a new. No, I'm doing that in the use cases. No, should rather be in here. And I'm going to call this the auth provider, auth adapter. So in here we write the template, and the template will be taken by the build runner and it will generate code based on it. So there are quite a few rules to templating. Now, first of all, you have to add the parts directive for the generated code. So we know that it will generate code for us and create a file in here in the same folder that you've put in the template. All right, so if the template was in the domain, it would put the generated file in the domain. Now the generated file will simply bear the same name of the current template file with a G. In the case of Riverpod, it's not always the same case for every other file or for every other thing, but in Riverpod you put the same file name with a dot and with a G. Now moving on, you add the annotation in Riverpod. Right, so we can see a few suggestions over here, but I'm not going to take them, so I'm just going to write it all out myself. Right, so Riverpod annotation, and then we create a class. So in this class, it's going to be auth adapter. And you put an underscore with a $sign and then the name again. Right, so these are the rules for templating. right? These rules aren't made by me. You just have to memorize them or remember, do them enough that you remember them. And you can see the Riverpod needs to be imported, and I have to import the Riverpod annotation. Now, after that, we've got this template, and we've got the part directive, and finally, we have to specify the return type of this class, or we have to specify what this class does, right? We can put in functions here, variables, that is class instances, and then that defines the adapter. However, in order, because we're not just writing a state manager, we're actually writing an interface adapter, so we need dependencies, right? So these dependencies will be our use cases. So this is how we do it for the interface adapter in Flutter, right? So these, because of the style of Riverpod, I'm actually going to have to mark the dependencies as late. So we have the forgot password dependency, which is from the use case forgot password. Wait, let me do that properly. You can see the use case forgot password. We could go back and do the same for all other use cases. So login use case, login. We also have the register use case, register. We also have the reset password. We have the, I think, verify OTP or verify OTP. And we finally have the verify token. Nice. Now after that, I'm simply going to create a constructor, but in Riverpod templates we don't have constructors, so we rather use the build method. So it's almost like Flutter. So override, and we override the build method. Alright, so the build method, this is where we can specify everything else and then specify a return type for the build method. Now the return type would be simply what this state. So remember, this is primarily a state manager, right? So what state is this managing? If this was the classic counter application, right, the counter application that Flutter gives you as a starting app for any Flutter project, right? So for that, the state of a counter page, right, would be an integer. So we're watching for an integer, and we're trying to watch the value of an integer change. And this is also the same thing in Riverpod as well. So whatever state you want to watch change will be the return type of your build method, right? So if you're trying to watch an integer change, it will be the return type of it, and so forth and so on. If you wanted a string or whatever else, and that will be your return type. So over here, let's say if it was a counter, you do this and then you give it an initial value. Right, so what is it going to be when the user starts the application and they haven't changed the counter? So you return the initial value. In this case, it would be a 0. Alright, so let's see. Yeah, it doesn't overwrite. So don't mind these errors and these things because we haven't generated the file yet. When we do, these errors automatically go away. If you've ever used freeze, then you're very familiar with this sort of issue. But I'm telling you, if you're not familiar with it, don't worry about it. It's alright. So this is the thing about Riverpod. It makes you, or it pulls you into the Riverpod world where you're in this little Riverpod world and you're within its constraints. So this is your environment, this is your world, and you're within its constraints. You have to follow its rules. It defines its own rules apart from Flutter or apart from the classic state management that we're very used to in Flutter. In this case, you can see there's no constructor. Your classes can't have constructors. So it's even going away from Dart, classic Dart as well. So we can't have constructors. We only have these things, build methods, right? So the build method acts as a constructor and you put the return type of the entire class over there, right? So now this pulls you into its world, and for that reason, you're not really certain where to go from here, right? Like I said, you can go ahead and do whatever you want with your state type. However, personally, the way that I handle this is to create a state for the entire adapter, right? So if my adapter has different use cases. For example, forgot password, login, register, reset password, verify it to be verified token. I will have states, a state class, a separate class called the auth state. Right, and this auth state will have different states. Right, so it could have logged in state. You could have an enum at the top for the different states, and it could return at any of those states. So when the adapter is loading, it will be auth state.loading will be true. If it's registering, if you want to have separate loading states for each of them, you would have, for example, auth state changing password, auth state logging in, auth state registering, auth state reset password, verifying OTP, verifying token. Now, how that would work would be in the UI, you listen for the separate or the individual loading states, and that comes in handy when you've got different logic for different states, for different loading states. Otherwise, I'd advise using the same loading state. So just one loading state called maybe auth loading. So that way, generally, just know that something's loading in the adapter. Otherwise, if you've got different logic, for example, for registration, when it's loading, you actually want to show registering as a text in the UI. In that case, you need to know when it's specifically registering and when it's not registering, when it's loading a different state, for example, logging in. And you also want to show that there. So in such a case, I'd advise you using different states, and we'd see how that works actually, so don't worry about that. So over here then we return the type of this class as that state, which would be auth state. Right, so let me go ahead and create that as a separate file over here. So new Dart file, auth state. Now in the auth state we can have a sealed class, auth state, and it extends equatable for testing purposes. Right, so when you're writing the automated tests, you want your state to be equatable, so that way you can expect that this state is emitted because they bear the same values. All right, so and over here override list of object, get props, and that is it. Right, so now this is the base class, and I can have more classes, and this will be final class auth initial extends auth state, and this has a constant constructor auth initial, so this will be the initial state, right? And then finally we have a general state class auth loading, a general loading state. Now I already promised to show you how the split loaders work, so this is for general loading. So all screens or all widgets that depend on this interface adapter will actually be watching out for a loading state for every action. Right, so we have different actions: verifying OTP, forget password, reset, verifying token, and the rest of them. All of them will be watching for this loader to know when it's loading. Right, so but if you wanted to show separate UIs or perform separate actions when it's particularly loading a specific state, you can actually abstract that particular state's loading, that particular function's loading. So it could be, let's say you wanted a special one for registry, so it would be registering extends auth state. Now you can still have the loading, forgive me for commenting it out, but you can still have the loading for other functionalities. All right, if you want every other functionality to have the same loading state except for registering, you can do it this way. But if you want all of them to have their own loading state, you can have login in, you can have resetting password. So you can see this is how I personally do it when I want to separate my states, my loading states, right? But in this case, I don't mind showing just one loader for all of them, right? I don't have any loading specific logic for any functionality. Now after that we have, so you can see how it goes. It has the initial state, It also then moves on to the loading state. This is my personal arrangement. The loading state helps keep me sane. And then finally, no, not finally though, and then these will be the success states. States. Alright, and after the success states we have come on mate. Alright. Let me do just one. No, do you know what? After this we've got the error states. If you've got more than one, normally we only have one error state. So the success states, we have a success state for each functionality, each use case. Right. So the use cases we have are OTP sent, login, logged in, registered, password reset, and the rest of them. Right. So we have to create a class for each of them, and we have first of all the OTP sent extends auth state. So this is delivered or this is emitted when an OTP has been sent, right? So over here it has a constant OTP sent, and we have a final class logged in. You can actually totally use the enum style, where you use an enum for each state and all that. But personally, I prefer this because it allows me to do better equality. Also, for example, in logged in, the logged in functionality returns us a user. So when you're doing this with classes and not enums, you can actually get that in here. So logged in. Now it will return as a user. Now, before we carry on, we've already got import over here, but I usually want to only import because this simply means that in the UI when listing, we have to import both the auth adapter and the auth state separately. But I want it to be such that whenever I import the auth adapter, I automatically have access to the state. So for that reason, I'm going to make this part to have a part auth state dot. Right, and the auth state will be a part of the auth adapter. Nice. And then finally we override. Let's copy the override and simply put the user in there. So the value quality would be for or with the user. Now after logged in, we've also got registered. We also have one for password reset. We also have one for, I'm forgetting my finals. Alright, we have a final, what have we? We've got the OTP verified. Now the token verified state tells us this dot is valid. It returns a boolean if the token is valid or is verified essentially, and this will be final bool is valid. We've got, no, not the final, not the finals. We've got this is valid. And finally we have our error state, so that would be class auth error extends auth state. We've got constant auth error, this dot message, final string message, and we paste our override, and this override will simply be the message. Alright, and finally we've got the adapter. Now over here we can make the return type of this to be an auth state. Build. Now after making that the return type of it, remember what I told you. With the build method, you actually need to give it the initial value. So when the user opens up the screen that uses the auth adapter, what will be the initial state of the screen. So return auth initial is the initial state. Nice. So this is it, right? So Riverpod does not really give us a style to follow for interface adapters or whatever. It doesn't really give, sorry, not interface adapters. It doesn't give us much of a choice, right? Or much of a pattern to follow for multiple state solutions. So I came up with this for myself, and if you want to follow it, you can. If you've got a different method of doing this, you can as well. Now, in order to initialize these, since we don't have a constructor, I'm actually going to initialize them here, right? And in order to initialize them, forgot password, it has to be equal to what? Has to be equal to a forgot password. But a forgot password depends on an auth repository. Now I'm going to pass it a new instance of the auth repository implementation. And the auth repository implementation wants a remote data source. So I have to pass it an auth remote data source implementation. The auth remote data source implementation wants it wants the HTTP client, so I have to pass it to HTTP. You can see what I'm doing, it's super long. So this is actually something that we'd have to do over and over and over again. So even if we've already initialized the HTTP client here, we'd have to initialize it over and over whenever we need it for each one, because each remote data source for these will need the HTTP client, so we'd have to pass it over and over. Now, when we need to access any of these from any other part of the widget tree, we usually will have to create them again. So for that reason, we've got something called dependency injection, because we've inverted these dependencies. These are inverted dependencies, so you have to inject them. Now, I don't want to do the injection there. I want to use something, a service locator of some sort that creates these things as singletons and provides me the same instance of them every time that I call for them in the widget tree. In order to do that, we could go back to the dependency injection container, right? So where we do all of the dependency injection, this is a service locator. It registers a service, and then it provides it to you in your code base whenever you reference that service, as we already saw with the cache helper and with the prefs. So in order to do that, since we have different features that will require different dependency injections, I personally like to put them in different functions and then call those functions at the top here. Right, so for example, apart from this, we would have await let's say auth init, and I prefer to make those private, auth init for authentication, and we await for that. Now the authentication initialization, I can actually take this and put it as its own function, and this would be await cache init. So now we have two. So the first one would be future void, and that goes to cache init, and cache init is this bloc. And finally we have the future void auth init async. If you remember correctly, what I already told you about injecting, so when we inject, for example, register lazy singleton, and we're registering the forgot password, so we have to register each of them in the registry, so each use case. So in this case, it goes to the repository. It wants the repository, and we're saying, all right, the repository, you can find it, but with the service locator. So the service locator looks in its registry and tries to find a repository that is an auth repository, and we're going to see that later. Now, but for now, let's go ahead and do the same for all other use cases. So login will require service locator. We do the same for SL. We do the same for reset password. we do the same for, I hope I don't forget anyone though. Verify ODB, SL. We do the same for, that is a long dependency list. I think verify token, yes, SL. And that is it. So these are the use cases. If I'm correct, that's 1, 2, 3, 4, 5, 6, and that's also 6. Yes. So now finally, remember that they all depend on a repository, and that repository, it's going to search for an auth repository. So since the auth repository that it's going to search for is not the same as the auth repository implementation, right, it's a different class, we have to specify and say, hey, register laser singleton, when any other dependency, or when anyone is trying to get access to a or to an auth repository, please give them the auth repository implementation instance. Do you see what I'm doing? And then we pass it the service locator for the remote data source. So if you understood what I did, kudos. If you didn't, then what I'm simply doing is I try to register. Remember that this is a use case. The use cases depend on this, but then these live in the domain layer. So what I'm saying is, when someone, meaning these use cases, are looking for an auth repository, or whoever else out there saying, give me SL at auth repository, please give them an implementation of it from the data layer. And this is what I told you about tricking our code base or our architecture. And this is loose coupling at its finest. And this is what I told you about tricking it to link the use cases, or to link the domain layer to the data layer without its knowing. So to this person, it's going to search for an auth repository that lives in its domain layer. But however, in the service dependency injection container, we rather inject something from the data layer. All right, so that is it. And then finally, we do the same for the register laser singleton data source. So the data source also, remote data source, also has both a base class and an implementation. So we do the same thing that we've done for the repository, and that is it. And then finally, sorry, what's the matter? A return type implementation isn't an auth remote data source. Are you certain? What have I done wrong now? Auth remote data source, auth remote data source implementation, not the repository implementation. I'm so sorry for that. And over here we see that it wants a client, an HTTP client, right? So we do the register laser singleton and we pass in an HTTP dot client. And we have to go over to the injection container and import the HTTP ourselves. Why? Because we need it to have an AST directive. So HTTP, all right. We can format the file. Nice. And over here, since every object in Dart, almost every object has the new constructor, right? We can go ahead and remove this syntax and rather use a tear off. It's called a tear off, right? So this is it basically. So we've done all of the injections. We could go back to the adapter and then initialize these dependencies with the service locator. So service locator forgot password is what you should get. So it queries your service locator and says, hey, find me a forgot password. Find me anything in your registry that is of type forgot password, and it will take it and pass it to that value. All right, so we can do the same for the rest of them. Login would be equal to SL login. And I can do 1, 2, 3, 4. All right, and this will go for register for reset password for verify OTP, finally for verify token. And over here we also do the same thing. It would go for register, and over here we go for reset password, and over here we go for verify OTP, and over here we go for verify token. Nice. So we've basically got a template down. Now we've got functions for each use case to handle their calls. So when we make a call to the forgot password, we make a call to the auth adapter dot forgot password function and we invoke it. So we have to create those functions. But before we do, let's go ahead and start our build runner generator. So I'm going to clear out the console. You have to come over to the console and run build runner. No, I think it's dart run build runner build, and you watch and you delete conflicting outputs. This simply removes any existing generated files if one exists. Otherwise, if you don't add that flag, then it will pause the execution and ask you, hey, look, we've already got this file. Do you want to override it? All right. And basically after that, you have to choose whether to keep the file or not, or manually delete it. Now that command failed because I added 2 dashes before the watch keyword. However, that was very wrong because the watch is not a flag. So these ones, for example, the delete conflicting outputs was a flag. So we added 2 dashes behind it. But the watch is certainly not a flag. So you have to run it without putting the double dash behind it. Alrighty, it's done now. And we can see the generated file over here. You can see it creates a provider for us called the Auth adapter provider, and per the old API you actually created this yourself, but right now with the new API it automatically generates it, and you can see it's also got two return types, the Auth adapter and its state, and you can see all that. Now whenever we create an adapter or we initialize an adapter in the presentation layer, for example, let me use a very good scenario. If on the home page we had an adapter that we're listening to for maybe fetching the user's details, imagine that we also had a profile page or a settings page where the user can actually go in and change their username. Now that changes the username on the server. Now when we do change username on the server, or when we initiate that changing process, right, the moment we click on that submit button in the profile page, the auth page, which was listening to the auth state adapter, the auth adapter, because it would actually, Riverpod is implicitly a singleton. It creates a singleton provider, and the provider remains the same throughout the lifetime of your application. So even if we've initialized a new auth adapter in the profile screen, the auth adapter that we get in profile screen will still be the same auth adapter that we had in the home page. So when we initiate that process and the auth state of the auth adapter that we had in the profile page will change into loading, we will see that the home page will also turn into loading. So let me give a better scenario. Imagine that you had in the home page you had 2 sections. One section was fetching favorites. Imagine that we had a product adapter. Now one section on the home page was fetching favorite products, and the other section on the same home page right below the favorites, right below the, let's say the first one was popular products, right below the popular products it was fetching featured products. They both depend on the same product adapter. Now this is on the same page, but these are 2 different widgets. Now if we created two different instances and passed them to these two different widgets and made them fetch. The moment the first widget, which is a popular sections widget, starts fetching with the products adapter, right, it will turn into loading. Now, it means that since the featured section is also listening for the auth state of the products adapter, it will also start showing a spinning loader. So these two separate things are going to be loading different states, but then listening to each other at the same time. So that also means that when the state changes to product fetched or popular products fetched for the very first section, which is a popular section, the featured section would actually start displaying popular products instead of featured products, because it's listening to the same data or the same state. So in order to actually get different instances, right, every time we initialize it, we have to do something. We have to pass in something into the constructor. And you can see the moment I change anything in the code base, oh my, it actually stopped watching because I put the build in there. So with the watcher, you have to remove the build if you want to watch it. So it generates all the files and then stops watching, or it doesn't listen. As you can see, it exited and I had to run it. So if you want it to keep listening recursively, as you can see, it's crashed, but then it's still waiting for me to change something. And the moment I do, let's see, the moment I save, you see it runs the build again. So it automatically starts watching for me. So the reason why I've put this here is to get a different instance every other time. Right, so now this is also good because it simply means that when I'm in the profile page and I've changed the user's data, I can actually get the auth adapter for the home page in the profile section by passing it the auth adapters, the home page's auth adapters family key, and then I can from the profile section trigger a refresh on the home page. Right, so it has pros and it also has cons. So, but I think its pros outweigh its cons. But moving on, we've got this, we've got that. You will understand that later if you don't. Right, when we're using this adapter in the UI, you will see the importance of having the ability to fetch different instances of this and also knowing exactly what instance you fetched. Alright, so moving on, we've got a future void for the login, and it's got required string email and required string password, async function. Nice. And then the moment we get in here, we change the state to be equal to auth loading. And if I save this, you see it rebuilds and regenerates the code base or the file, the module. So now after that, we get a result from calling the login use case. And remember, the login use case has got a call function in it. This call function, so meaning that the class is actually invocable. So we can pass in login params since it's got more than one parameters, and we pass in the email and password, which is automatically done for us, and we can close this down. Now finally, we'll fold the result. This is how Dart's package works with the either or. So when we've got an either return, so this returns either a failure or a user. So in order to get access to both of them and give them specific instructions depending on what's the return type, we fold the either. So we fold it. Now when you fold it, it gives you access to two functions. First of all, the left function. You can see if left. So over here, the if left function will return us, or it will give us the failure that it's got, and we can do something with that failure. Or if right, it will give us the user. and we can do something with the user as well. Now, when it's a failure, we simply want to return, we simply want to change the state to become equal to auth error, and we pass it the failure dot error message as its message, right? Pretty simple, I believe. And over here, when there's a user, I actually want to change the state to be equal to logged in state, and pass it the user, so we get access to that user. Now, I actually want it to have a general user provider over here, right? So that way, all of the pages in my application can actually get access to the current provider. Simply the same thing that Firebase has, the firebase.instance.current user. I actually want to have that sort of thing over here in my Riverpod application. Now, since it's going to be very common to everyone, I'm going into the common and I'm going into the app. And over here, I'm going to create, let's put it in a provider package, providers, and this will go into providers. No, let's just call this Riverpod. It's Riverpod providers, but yeah, whatever. And over here, we have the current user provider. So this time it's not an adapter, it's a provider. Remember differences. Now, as always, template definitions, we put the current user provider .dart .g .dart, and after that we have to at Riverpods, this time using a capital R. Why? Because we have something to do. So over here, I don't just want it to, let's write the class first before we talk about this. Current user will be extending. So this simply means that it will generate a provider called a current user provider. So extends $$ current user. Now, the reason why I've made it capital is because I actually need to pass it an argument, and now that argument is simply the keep alive argument. And in order to pass arguments, you have to use the capital R Riverpod annotation. Now, keep alive, I'm going to say true. Why? Because when, for example, we get to the home page and the home page was listening to this, or sorry, not the home page. When, for example, because the home page is very basic, right? So when, for example, we get to maybe the splash screen, and the splash screen is setting or using the current user. After the splash screen gets destroyed and we get moved to the home page, the current user will get tossed. It will get yeeted. So it no longer exists. It will be crushed and destroyed. So we want to keep it alive throughout the application's lifetime. All right. So for that reason, I'm keeping that there. Now, override. Now, the return type of this class, or what we're tracking, the state that we're tracking, is of type user. And that user is actually nullable. So when the user is null, we know there's no user or there's no current user. Now, we also have future void. And you can see when I save this, the build runner will also detect this. So because I'm watching the build runner, so whatever providers I create, it will automatically regenerate them. And over here we have a future void set user and user. This doesn't have to be future. Don't mind me being silly. And over here we can simply if state is not equal to user, state will simply become equal to the user. Now we can save this and it generates that user provider, which I for some reason can't see, but it's there. So where are you? It's there. Well, Android Studio is doing some magic, so let's let it cook, let him cook. Alright, so moving on, while that cooks up, yes, finally, it's finally here. After all that time, this is it. So we've got a current user provider, and that is it. So now over here, we can actually, from here, change or set the current user. So this will be run when the user logs in. Now the moment they log in, we actually want to not only change the state, but also we want to notify the entire widget tree that ref.read, and we notify the entire widget tree that the current user provider dot notifier dot set user has a new user, right? So now what is this? The ref is a reference. A reference is a Riverpod reference. It's a way, it's similar to context, right? The build context. So the same way that you can use the build context to do things, to carry out actions, right? To find values in the widget tree. Similarly, you can use the ref to find values or find other providers in your Riverpod providers tree, right? So we've got a different Riverpod provider called a current user. We can access that current user by using the ref.read or any provider at all using the ref dots, and you can watch or you can read. Watch simply means when it changes, alert me, all right, let me know that something has changed. But over here, I don't care whether it changes, I'm just setting a value. So whenever you're setting a value, always use a read, but whenever you're going to use a value from a provider, always use watch. So in the UI, when you're using the value of the current user, you'd rather use ref.watch, and then you pass in the current user provider, and that is it. It will return you a value that actually updates the moment someone changes that current user or the thing that you're watching for. So over there, the login's done. So future void register. We required string name. Required, I think, email. Required string password. Required string phone. Nice. Now finally we set the state to be equal to auth loading. Now whatever part of the UI is listening for the auth adapter will actually be notified, right, that it's loading. So something's loading. Show a spinner. Await for the register. Register params. And we get name, email, phone, and that's super easy because we're so lazy. I'm so lazy, not you. You lot are good people. Well, that's not to say that lazy people aren't good people. Well, I digress. Result will be equal to result of fold. We've already got the results and we fold it. So I hit tab and it automatically gave me the left and the right. So it gives you the left value. In my case, I'm very certain the left value is the failure, and in the right value it's void. So I'm going to replace that with an underscore because I don't care about it. So over here I set the state to be auth error. A failure dot error message. Oh, my hands hurt, my arm, my wrist hurt. And over here we set the state to be equal to constant OTP sent. As you can see, the states are coming in handy. And there you go. That is it for the register. And then moving on, we've got forgot password, we've got verify OTP, we've got reset password, we've got verify token. We've got a lot. So you can stick with me. I'm just going to write them. We already know how to do them, but I'm going to write them and speed through it so I don't bore you. If you want me not to speak through it, you can slow it down. So, yeah. So now, carrying on. By the way, this was rather registered. So this was in the register function, so registered. My bad. I'm so sorry. Alright, so carrying on. Now over here, if this is valid, I simply wanted to change the state to token verified and give it the is valid value. And after that, if it's actually not valid, so if the token is not valid, we want to reset the current user provider.notifier, want to reset it to become null. Right, so meaning their token has expired. You don't want them to remain with a value. You don't want them to have access to that account any longer. Right, so whoever's got the phone at that moment, the token's expired, so we set their current user to be null. Right, so that said, this is it for the interface adapter. And this is how interface adapters work. So now in the UI, we can directly call the reset password. If we want to reset password, we can call anything that we want and then listen to the states. So the state of the auth adapter provider, and whatever happens, whatever states get emitted, we see them affect the UI because we put conditionals in the UI. If the auth adapter state is if the auth adapter state is equal to maybe locked in, meaning the user successfully logged in, and we want to push them to the home page and then get the user from that state, because the state over here has logged in and logged in has a user. So we take that user and we pass it, which we've already actually set generally overall over here to, where was it, login. We've already set it to the current user provider, but in any case, this is it. This is how it all works, and yeah, quite beautiful, isn't it? So that is it. Finally, we can go ahead and build the login or the authentication user interfaces. We've already got a fair idea of what we're meant to do, or the authentication logic. The moment the app starts, it throws them to the forward path and the redirect runs first. If you already know how go router works, you already know that the redirect will run first and check if there's any need to redirect. If there's no need to redirect, it moves on to the builder. And the only case where we need a redirect would be when the user does not have a session token, or they do not have a user ID, or they're a first timer. Now in that case, and then not a first timer, and in that case we push them to the login screen. However, if they don't have a session token or a user ID registered as system, but then they're a first timer, we simply know there's simply a first timer, right? So we don't expect them to have a session token or a user ID. So in that case, we push them to the onboarding, which is what takes them to the builder, because we return null. All right, so that takes them here, and over here we check, and when they're a first timer, it takes them to the onboarding. That is simple logic. However, when all of that is not true, they're not first timer, but they don't have these things, or these things are invalid, we don't know about their validity yet. We just know that there's a session token and there's a user ID. Now we push them to the splash screen. It shows them the splash screen for a bit while doing all the heavy lifting behind the scenes. So let's go ahead and implement the splash screen. Now, over here, we can start the moment this splash screen gets built with override init state to take over that. The moment that happens, we simply call the widgets binding, because we don't want to do that while there's a build going on. So add post frame callback. Replace that with a wildcard. And boom. Now finally we're here. Now we've got something called an interface adapter, which was what we created over, I think that lived there, over here. Right, so we've got an adapter, and the adapter in this case is using Riverpod. Now the adapter has already got its things set up. However, we still need to tap into the adapter and call the verify token. So the very moment they log in, we call the verify token, and it will verify the token. Now, in order to use that adapter with Riverpod, in order to get an instance of this adapter, we can totally convert this to a consumer stateful widget, which is what Riverpod uses. You could go and read its documentation, but I'm putting it very simply for you. You simply convert it to a consumer stateful widget, and you can convert every other state to a consumer. So consumer state, and this also turns into a consumer state. And we've got a complete Riverpod consumable widget. Now over here, it will provide us with a ref, and that ref is globally available within the state of this widget. So over here, we could go ahead and say a ref dot, and we want to say read, meaning read the value of something, but don't listen to it. Now a listener, we probably already know what a listener is, because this isn't for beginners. So a listener simply listens for changes in a listenable. Now a Riverpod provider, for example the Auth adapter, is listenable. So we could go ahead and listen for changes and say, alright, listen for this, and when this changes, change my UI to do this, or change my UI to do that, or carry out this function for this scenario and for that scenario. Now these are things we can do, but with read simply means read it and don't listen to it. Now when you want to listen, we've got something called a watch, right? And we've also got listen, which we'll see how to use later down the line, just very soon to be used pretty soon. We use a read because we're going to carry out a command and we're not listening for values. Now what are we reading? We're simply reading the auth provider adapter, auth adapter provider, and we invoke it because it's got an where is it? Yes, this is it. So because it's got this, the key. So when you've put an argument or a parameter into the build, you will always have to invoke your provider, whether you're passing it a value or not. So we're not passing a key at the moment, but we still need the invocation because that's how it works. Now if there was no parameters or arguments being expected, we don't have to do this. We could totally do this and say .notifier. However, since it's got an invocation, we have to say .notifier, which will give us access to the notifier, and we want to set a value in this notifier so that every other listener everywhere else in the tree will be notified when something changes in it. Alright, so we go ahead and say .notifier.verify token. Now this is how we carry out actions in Riverpod. When you want to carry out an action, you have to tap into the adapters provider, which has been automatically generated, right, in the auth adapter G. We can see that over here, and you tap into that and you call a notifier. It's basically a value notifier, right? Call the notifier on that provider and you call the function that you want to invoke. Now in our case, we're invoking the verified token, but we're not going to await it because we can listen to it over here. Now over here, what I'm simply going to do is to ref.listen, right? So it's a listener. I'm registering a listener and saying whenever the auth adapter provider, we invoke it, whenever this. Now it gives us a previous and a next, meaning the previous state and the next state. Now if you remember correctly, we've got the state and we're setting the state of auth loading and so forth. So that state is what we're listening to, and we can see the state is an auth state because we've specified an auth state over here as a return type of the entire provider. So the state, the previous state and the next state. Now the one that you want to always listen for would be the next state. Why? Because the next state is what is coming up, the very current state. I don't know, I prefer to call this the current state, but I don't know, they've put it that way, so automatically implicitly written as next. So I'm leaving it as this and I'm going to listen to it. Alright, so over here, if next is token verified, right? So if the next state is of type token verified, I actually want to check if next dot is valid, because a token verified has an is valid property, right? So we're tapping into that property and saying if it's valid, I want it to do something. If it's not valid, do something different. We actually want to get a ref.read and we want to get users data, right? Get user by ID, but we don't have that in our authentication because we don't get user by ID in the authentication route and from the server, from the API. It rather lives in a user's endpoint, on the user's endpoint. So I'm actually going to create a separate user feature and create the data domain and the interface adapter, and we will use that to say read. So, but for now, I'm going to replace that with a to do, and that would be get user data. Of the user adapter. Right, so now the moment after we do that, actually, we go ahead and we listen for the current user. Let me show you what I'm talking about, because where is my auth adapter? So you can see over here we've got login, register, forgot password, verify OTP, verify token, reset password, but we don't have a specific functionality for fetching the user's data, probably by their ID or something. Alright, so we go ahead and we do that later when we implement the users feature, which we're going to do real soon. Alright, so now over here we go ahead and we say else. Now else we await. If it's not valid, we actually want to declare the cache. So cache helper dot reset session, and we actually want to invoke this because we're using the service locator, and over here we mark it as an async function in order to await that. So we reset the session, and finally we go ahead and we context.go. Now this is from the Go router, so we use context.go, which is also similar to navigator.push, right? Push replacement, because you're replacing everything in the stack, in the route stack, in the navigation stack rather, and we're replacing it with whatever value, whatever route we specify here. Now in this case we actually want to go back to the initial route, and that would be the initial route. Now the reason for this would be if I reset the cache helper, right, and we go back to the initial route will actually try to redirect again, and it will check for the get session and a get user ID, and because I've reset that, it will not find the value for these, so meaning this will ring true and it will take them automatically to the login page. Now, so we've got quite a few things to do here. Yeah, so can't use built context. Also, this is also actually very risky. This is another issue that I've got with Riverpod, where it doesn't automatically provide a listener, and we have to do this. We also can't listen in the init state. We have to do it in the build method. So we definitely have to schedule a binding dot add post frame callback to make sure it doesn't run while the build method is running. So for that reason, because we're going to use that a lot, we're actually going to be using the ref.listen quite a lot. I'm actually going to add or create a utility, right, in the core utilities to handle that, to handle the calling of function or carrying out functions while the build method is running, to prevent that essentially. So I'm going to go over to my utils and go over to core utils, and over here let's call this a post frame call. So it's going to be a static void post frame call void callback callback. So we pass it a callback and we call the scheduler binding dot instance dot add post frame callback, and we replace that with an underscore because we don't care about the timestamp, and we boom do the callback. That is it. We invoke it, invocation. So we could go back or come back here and we can totally do the core utils dot post frame call, and we go ahead and we context.go and we go with the / route. Alright, so this is it for the for a case where the token was verified, however, the token was not valid. Alright, but what if the token was not verified? What if, while trying to verify, we hit an error? So it would return us an auth error. Nice, and auth error is also a state, right? We could go back and look at what the auth error is. It's a state and it contains a message. Right, so now over here we could go ahead and say if there's an error, we can check first of all if next.message starts with 401, right? Why am I checking if it starts with 401? Because over at the, let's backtrack our steps. Over here, when there's a failure, for example, when verifying token or for any other functionality at all, when there's an error, we return the failure.error message, and the failure.error message always starts out with the status code. Now the status code, if the status code was 401, meaning it's an unauthorized error, something's gone wrong, this person's not authorized. Alright, something's gone absolutely wrong. So what we actually want to do is also to reset this. However, before we do that, I'm actually going to copy that over. Now, immediately after we redirect, we actually want to return. Right, so exit this, don't check for any other states. Right, so now all we've got left would be this, to get the user's data from the user adapter. Sweet. Now over here we can cancel that. We're not adding to any version control. Now over here we could go ahead and start with the user repo. You could go back to the server and check for the functionalities that fall under the user's route. However, I already know these, so I'm not going to waste your time, and I'm going to write the functionalities offhand. So that's constant user repo. Nice. Now over here we've got a result future, and it returns as a user. Now this would be get user, nice, and we get user by their user ID, and we've got a result future user, update user. Now when updating a user, we've got required string user ID, required data map, update data, the data that you're trying to update, and finally we've got one more functionality, and that would be result future. Now for this function, we're actually trying to affect the user's payment profile, right? Get user payment profile. Because the user actually gets the payment profile stored by Stripe or whatever payment gateway you're trying to use, but we get that payment profile and we take the user to that payment profile, and this is what we're trying to do. So I'm actually going to speed run through the rest of it. No, let's actually have some refresher. So let's take a bit. So now we do, still under domain, we've got the use cases. Nice. Now over here we've got a new Dart file. Let's do get user. Right, you already know what I'm going to do. I'm going to write a class for each of them. So get user payment profile. And then finally, got the update user. Now let's start off with the get user. Now the get user is quite straightforward. As you already know, we write a class get user, and it will extend a type of use case either the use case of params or the use case of no params. You can go back to the use case tutorial section if you don't remember exactly what we're doing, but I'm going to talk you through it though. But we need to extend a use case. Why? Because in this case it's got parameters. Why are we doing this? Because we need to have access to that call function. We want it to be a callable object. Alright, so over here it returns a user, and that is a return type, and then finally the param type. Param type is a string. If it had multiple params, we'd have to create a separate a separate class for it. And we go ahead and we get the user and user repo, and that becomes a repo. I told you I always make sure that my dependencies, when I'm inverting them, are private. I always do that. Now we have to do the override, and this will automatically write the override for us, and it's string params, and we get repo.getUser params. Nice. And we do the same for the get user payment profile. So let's do this. I was actually going to copy paste it, but for tutorial purposes, let's go ahead and do it from scratch again. So remember the function name, but with Pascal case. All right. So get user payment profile extends. In this case, it has some argument, some parameters. So extend use case with param. So param type is a string, and return type is also a string. So because it returns us the URL for the payment profile on Stripe. So we basically use a web view, or we launch a separate web page if we're on web. So this project's going to literally run on web as well. So final user repository, which would be the repo. Now basically every use case will depend on the same repository. All right, in a feature, in a particular feature. I mean not every use case in the entire project. So over here we go ahead and let it do the override, and it does the override quite perfectly, and we simply return. I'm going to use an arrow syntax, and it's repo.getUserPaymentProfile, and we pass it the params. Nice. And finally, the update user. I already know. Now, what type is it? Can you guess? The type is a user, because we've got a user type here. This. But then the parameters are multiple, so it's got more than one. So in that case, we're looking at a update user params. Remember, the name of the params class will always match that. Alright, so now the reason for this will simply be for testing purposes. And when you start doing unit tests, then you see that you will definitely need those. But carrying on, we have update user, and it's going to be this dot underscore repo. And then we've got the final update user. Aha, what am I doing? Final user repo, not update user, underscore repo. Nice. And we override. Create one missing override, and it's going to take the type of that for the params, and finally return the repo dot update user. And the user ID will be the user ID from the params.userid, and this will simply be params.updateData. No, stop it. And finally, the class, the params object extends equatable constant update user params. And we've got required this.user ID and required this.update data. And we've got final string user ID, final data map, update data. All right. Now over here we remove the to do and we return something, and that would be the user ID and the update data. Sweet. Now we've got our use cases done. Up next we've got the data layer. Alright, so that is a new package. Over here, oh my word, that goes to data. And we want data dot repos. Alright. Now over at data we also want a new package called data sources. Sweet. Now over at the data layer we're going to have the implementation and the data sources. Right, so over here in the repos we have a new Dart file. I'm closing every other thing, close all the tabs, and we've got user repo implementation, and as always we've got dependency inversion, in this case the remote data source. So inverting remote data source, which you don't have yet, but whatever. User repository implementation implements the user repo. I've got to do something similar for the data sources. New Dart file that goes into user remote. Remember, we could have a local data source and a remote data source. So remote data source for when you're fetching data from a server, and a local data source when you're fetching it from local. Now this becomes, do we make it sealed or abstract? We could either make it sealed or abstract, it doesn't matter. Yeah, but I'm actually going to make it an abstract because, yeah, it makes more sense to make abstract rather than a sealed one. So it's going to be an abstract class user remote data source, and close that. Now over here we have quite a number of them. I could go back to the user repository, copy and paste. Right. And over here we've got a future. And over here it returns a model. Remember, in the remote data sources, what am I doing? No. I have replaced the wrong thing. What am I doing? Constant user repo. User repo implementation. Nice, and then we wanted to paste that over at the remote data source and not the repository implementation. So that goes to future, and we head over to the user, and this, remember, it always becomes a model in the remote data source. And over here we've also got a user and a user model, and over here we've got a future string, and over here a data map. Nice. So we could go back to our repository implementation and depend on the remote data source final dot underscore remote data source user remote data source remote data source, and it becomes that. Create 3 missing overrides. Now each function has to be an async function. Nice, and we put a comma, better formatting. Nice. Now carrying on, moving on, we can start with the get user, and over here we've got a simple try catch. It's basically the same for every data source, every repository implementation. That depends on the remote data source or a local data source. All you have to do, if it returns a value, you have to get that value of the final result would be equal to the remote data source or the local data source dot the function that we've got here. Remember, it's got to be similar. You pass in the same argument, the same the parameter becomes the same for the argument. And then moving on, we can return right over here. Have to auto import right, and over here we'll return the result. Now if it's a void value, we'll replace it with null, and over here we don't save it to a variable, we simply await it without saving it to a variable. Now over here we can on server exception, because we're very certain that we're only catching server exceptions, catch an E, and over here we'll return a left, and it returns a server failure dot from exception E, and that exception's already been passed. Sweet. Now we do the same for the user at the get payment profile, and it's pretty similar. So we copy and paste that. Very risky, but over here we also get the result, and it's the same from exception. Over here we do something also super similar. No, what am I doing? Something super similar. However, over here we're updating user. Update user, and you can see it automatically fills itself up, and we return the result. Otherwise we return an exception. Right, so these things become easier the more you do them. So we have to close this up. Right, so they become easier the more you do them, because it's basically the same, and that is why clean architecture, or having an architecture, is basically nice. And regardless of the fact that clean architecture has a lot of boilerplate, it's something that you can easily replicate because they're all simply the same. It's all remote data sources, all repository implementations depend on a remote data source, and every remote data source and every repository implementation uses the remote data source in each function to call a function of the same name and pass it the same arguments, right? And then return and then listen to the server exception, catch the server exception, because we've customized it, and we always certainly do customize it if you want to. Now this is custom, but if you don't like it, you could do whatever you want. But basically it's a structure, beautiful piece of code, and we could go back to the data sources and do the implementation of the data sources. So carrying on over here, we could write our, first of all, the endpoints. Right, we've got a few endpoints. We can do the constant get user endpoint. Well, let's just call this the user's endpoint. Simply calls users, and we can ignore this. Ignore. I taught you this before. You could head over to the data analysis, and over here you could right click and ignore for the entire file, and that ignores it at the top of the entire file. You could totally also just follow Dart conventions. Personally, I don't want to follow them, but you could do whatever you want to be fair. So user remote data source implementation implements the user remote data source. and we go ahead and do the overrides. Now over here, it depends on the network client. That would be user remote data source implementation. This dot underscore client. Final http dot client underscore client. If you are using DO, it would be your type DO, but it would still be a client. So over here we import http.dart as http. We'll close that up. And over here we start the implementation. Now this is going to be super similar to what we've already done. And over here we simply try. And we can go ahead and do a copy paste. So I'm going to copy and I'll be right back. Alright, I'm back. I've copied and I'm pasting. Alright, so we've got a server exception. Paste. We've got a debug print. We need the foundation, all the widgets. Going to go for foundation, and that is it. So the 500, we say it's not your fault, it's ours. And over here we do the trial. What are we trying? So final URI would be equal to let's do URI.parse, and since it's on local, whatever happens, whether it changes or not, we don't really care. Now over here it becomes network constants dot base URL. Now when that changes, we change that over at the network constants and it will reflect everywhere. Now over here we use the user's endpoint, so that is HTTP localhost on port 3000, for example, /, because this user's endpoint already has a /, so we don't have to manually add one over there. Now over here we close it with the user ID, and that goes to the user ID. Boom. Now we've got a URI. Now moving on, we've got a final response which will be equal to await client.get, and we get the URI with headers to be cache.instance.sessionToken.toHeaders. And over here we also, really important, we need to make these async. Now after the response been got, we actually want to fetch the payload, which is payload becomes JSON decode, and it's going to be response.body, and we're going to cast it right here as a data map, because both the errors and the data will be data maps, will be maps, map types, objects, JavaScript objects. Right, so we don't have a list of errors or something of the sort that turns it into a list, or we're not expecting a list of data. We're expecting both of them to be data maps. Right, it could change depending on your server architecture or your configs. It could totally change. Now after that we have to wait for the network utilities dot, and we want a renew token. Right, renew token with the response, and if the response.status code is not equal to 200, error response will become error response. We want a from map, so we're using that one, the from map, and we give the payload, and that goes there. And otherwise we throw, I believe it's called server exception, if I remember correctly, error response dot error message, and the status code will simply be the response dot status code. And we go ahead and we cache that over here. Alright, cache that here, and over here we're not done yet. So after all of that is done, if the response is not 200, it throws, but if it is 200, we go ahead and return a user model dot from map, and we give it the payload, because payload is a map. And now that function no longer screams. It's alright now, it's a lot better. Alright, so we do something super similar with the rest of them. So we go ahead and we copy paste for the let's do update user first, because it's a lot more similar than the other. also returns a user model in that. So let's go ahead and do that first. So over here we've got a URI, but over here we also do the same thing, right? Users endpoint with users. The only difference would be that this changes to put and not a get, right? So over here we put, but then the body, the body becomes JSON encode, and we encode the update data. All right. What else could we do differently? We do this as a data map or renewed a token because it returns a user model, just going to come in the form of a data map, and the errors will also come in the form of a data map. So we create an error, and this will actually either return that or in some cases return response.statuscode.201. So if it's not either, we go ahead and we throw an error and we say yes, that didn't work. If otherwise, we return the updated user. Right, so moving on. Yep, that works. That looks pretty decent. Now, moving on, we've got the get payment user profile. Hopefully, I haven't copied over my copy. Yes. All right, so the clipboard is still intact, and over here we use the user ID / payment profile. Now the response will simply be a get, and we get the URI with that, and the payload becomes a data map renew token, and if not 200, sweet. Otherwise we return the payload at URL, and we cast that as a string. Nice. So that is it for all of it. So you can go ahead and implement the adapter, the interface adapter for the users feature.